application bar, you can see here the list of all file operations. The save button, undo and redo. On our right is our profile and help section. Here you can access your Autodesk account. You can modify your desired preferences. Going back, you can also work offline, disconnected to the internet, and exit the application or sign out. The other one is our help section. I'm gonna move this one to have a good view. In our profile section, you can ask for learning and help. You can find step-by-step tutorials, what's new, be directed to Fusion 360 Community Gallery, a list for diagnostics, and information on the Fusion 360 release you are using. Another important part of our interface is the toolbar. Use the toolbar to select the workspace you want to work in and the specific tool you want to use in the workspace selected. So currently, we are now in the model workspace. Another one is patch. Next one is the render workspace. Next is the animation workspace. And recently we have this new one, the sim workspace, simulation workspace. And finally, the cam workspace. Another area to explore on our right is the view cube. Use the view cube to orbit on your design or view the design from standard view positions. Notice if we hover our cursor on the cube, you can see a blue highlight. For example, let's have a top view. If you want to go to the isometric view, we may go back and click this little house. So this is home. And now we are being brought to the isometric view. Going to front view. Notice there are 4 tiny triangles. Let's select this one. Select this one. Again, going back to isometric view. Let's try right. Clicking the left triangle. Notice we also have these 2 curved arrows. So let's click this one. Click this one. Click the other one. Going back to home view. Notice if I hover my cursor on the view cube and press and hold our left mouse button, we can do a orbit. Moving to our left is our browser. The browser lists objects in our design. We use the browser to make changes to objects and control visibility of objects. We can select this tiny white triangle to expand. Here is our name views. Selecting top, front. Another one, if we want to change our units, we may select this one as well. So if we want to select inch, we can do that. Clicking cancel. Here's our planes and axes. Our bodies and sketches. Notice that these bulbs are similar to AutoCAD. So if we turn off this one, as you can see, we hide the body, turn on, turn off. So again, this is our browser. Another part of Fusion 360 interface is the canvas and marking menu. The Mark-in menu contains frequently used commands in the wheel and all commands in the overflow menu. In the next lesson, we will explore the lower part of the Fusion 360 interface. At the bottom, this is our timeline. The timeline lists operations performed on your design. In other typical CAD programs, notice that their model history is located in the browser. But for Fusion, it is specifically located in the lower portion. In design, we should always anticipate for changes and revisions. This CAD model is simple and has few features and history, but in the future, as you go on and create complex parts and assemblies, your timeline will be very populated. That is why it is a valuable skill to be able to look back in a timeline to make revisions. Another point to consider is, what if the model was created by someone else, or was passed down to you to continue or make changes? Moving forward, if we hover our cursor on any feature in our timeline, notice that it also highlights that feature in our 3D model. In addition, if we left-click on any point on our 3D model, we are given 3 small forward slashes. If I want to locate where this chamfer is, I can left-click, and now I am able to locate our chamfer. Clicking anywhere on our canvas and double-click my middle mouse to zoom extents. Also, I can drag operations to change the order of a specific feature in our timeline. Left-click and drag chamfer 1. Makes it our latest feature in our timeline. I can right-click to make changes to a feature. So I can modify this extrusion. I'm gonna hit cancel. We can also grab our timeline marker to go back to a past feature. Dragging it again. On our left, we have buttons to move to the beginning, move to the end, and make incremental steps like previous step, next step. So I'm gonna click move to the beginning and hit the play button. So this is a good way to assess how a model was created. Again, moving to the end. Finally, the last section of our interface is the navigation bar and the display settings. The navigation bar consists of orbit. Seldom do I use this one, as I prefer using a shortcut by pressing Shift and holding middle mouse simultaneously. Another one is look at. So if I select a surface, it aligns that surface to my view. So going to home view, selecting look at again, selecting the surface, pan. Another shortcut for this is holding our middle mouse. Next is zoom. Of course, you can use your mouse wheel to zoom in and zoom out. Fit. So if I zoom out, another shortcut for fit is double clicking my middle mouse to zoom extents. Under display settings, we have viewports. Going back to single view, grids and snaps, and display settings. In the next lesson, we will learn how to create sketch geometries. 3D model, we are required to select a plane, sketch on a plane, ensure that it is a close profile, exit the sketch, and finally extrude the sketch. Going to Model Workspace, selecting Line. So now we are prompted to select a plane for us to sketch. I'm going to select the XZ plane. Notice that the plane automatically aligned to our view. I'm going to select the origin. Key in 100 millimeters. Left click. Key in 50 millimeters. Left click. Left click again and go back to the origin. So notice that the color suddenly changed, indicating that this is now a close profile. So going back to sketch, going to the drop down, let's select center diameter circle and just eyeball to place it in the middle. Key in 25 millimeters as our diameter, hitting enter. So now we have two close profiles, this one and this one. So going to stop sketch and going to home view, we can now extrude any of these profiles. So going to create, selecting extrude. So I can select this profile. I'm gonna hit Control. So notice that I have two selected profiles. Dragging this one upwards. Holding my middle mouse button to pan. Zooming out. Let's key in 30 millimeters. So finally, we have a 3D model extruded coming from a close profile sketch. So notice in our browser, we have now a new sketch named Sketch 2. Fusion 360 automatically hides the sketch because it was consumed. So going back to sketch, let's create another extrusion. This time a cut extrusion. Selecting this plane. Going back to sketch. Selecting center diameter circle. And I'm gonna just make an eyeball to make a circle on the center. Let's key in 20 millimeters as our diameter. Pressing enter. Going back to stop sketch. Right click. I'm gonna select press spool. And now we are prompted to select a region. Selecting this profile. Notice that if I drag it leftward, we are now creating a new material or an extrusion. But if I go on a different direction, notice that it turned to a different color, specifically red one. So this one is indicating to us that this is a cut extrusion. As you can see, the operation is now cut. And again, going on a reverse direction, the operation is a join one. I'm going to drag this to create a hole on our block. I'm going to press OK. So now we have created a cut extrusion. Finally, let's create a simple slot. So I'm gonna select line, selecting this top plane. Just an eyeball. Let's create a line, the first point here, going here, and I'm gonna hold and press my left mouse. So notice it turned into an arc. So I'm gonna release my left mouse button, create another line, left click, again I'm gonna hold my left mouse button and connect our arc to this endpoint. I'm gonna stop sketch now. Go to create panel, select extrude, select this profile, and let's extrude this by 3 millimeters. Pressing enter. So now we have an extruded slot in our 3D model. In the next lesson, we will learn the importance of geometric constraints in our sketches. Now, before we dive in, I would like you all to be aware of organized projects. Under Data Panel, we can see the list of our existing and shared projects. Here, we can create a new project. Now, I'm going to hide my Data Panel. No need to follow along for now. I'm going to create a quick model to save. Going to create, selecting box and creating this on our XZ plane. I'm going to make a quick rectangle. Give it a length of extrusion. Clicking OK. Now, if I hit save or a shortcut key, Control S, notice that the list of projects on our left side, and also we are informed that this project will be saved in JawMark's first project. Now under JawMark's first project, you can see that I have a list of folders and a bunch of other files. So I'm gonna click cancel. Moving forward, let's now familiarize ourselves with the essential tools under the Sketch drop-down menu. Keep in mind, whenever we grab any tool in our Sketch menu, we will be prompted to select a plane or planar surface. For example, if I select a line, I'll be prompted to select a plane or planar surface. I'm going to press escape to exit from our line command. Let's start with the line. We have 3 ways to enter the line command. One, by clicking here immediately, or clicking sketch to access our drop-down menu, and by pressing letter L on our keyboard. A quick tip: let's always familiarize ourselves with the shortcut keys to speed things up and in order to save time. Now I'm going to press letter L to access our line command. Now I am prompted to select a plane or a planar face. I'm gonna select our XZ plane. How do I know that this is my XZ plane? If I go over to our browser and select this one and hover my mouse over these items, so I am given an indication that the plane that I was referring to a while ago is the XZ plane. So going to the plane and selecting this one. I'm going to hold my middle mouse button to pan. Now we are prompted to select our first point. We have a clear indication that we are in the line command because of the symbol at the lower right of our cursor. Unless required, it's best to disable Snap to Grid. So going to Grid and Snaps, clicking Snap to Grid. So let's now select our first point, just anywhere here, making an eyeball. Left click. So now we are prompted to enter a length for our line, which is currently in 68.411 millimeters. If I hit my tab key, we'll be switching now for our angle. So I can cycle through these two choices by pressing tab. So let's now enter 50 millimeters. I'm going to press enter. Notice that we're given a padlock, meaning that the 50 millimeter is now locked. So if I key in 45 degrees for our angle and press enter and move our cursor in a circular motion, notice that we're given an increment of 45 degrees. So left click again. I'm going to pan to center this to our view and zoom. Notice that we're now prompted to select our next line. So without clicking or entering any dimension, I'm going to left click for now. So because we did not input any dimension, notice that for our second line, we were not given any dimension, which is denoted by a black color. So I'm going to press escape to exit from our line command. And again, pressing letter L on our keyboard to enter line command. Let's make our first point, and without keying in any value, notice I haven't pressed left click for now. Again, if we press left click and hold it, notice that we are given an arc. So if you remember, we have previously discussed this in our past video. So now I'm going to release my left click, and we're now done with our arc command, and now proceeding to our line command. So let's just press here, left click, and go back to this endpoint. Notice that we have created a new region. So feel free and take time to explore the line command. The line command is a very commonly used tool for sketching. So I advise to get used to it. Moving forward, let's create another line. Left click here, left click here, left click here. Notice that in our canvas, there's a green check mark denoting create and continue. If we select this one, we will be disabling our chain of line segments. So clicking here, notice that we are now prompted to select a new point. To conclude, let's keep in mind the organization of our projects and taking mastery of the line tool. In the next lesson, let's discover splines, points, and polygons. For spline tool, going to Sketch, selecting spline. So now we are prompted to select a plane. Let's select our XZ plane. In a mathematical definition, a spline is a continuous curve constructed so as to pass through a given set of points and have a certain number of continuous derivatives. Let's now create our first point. Left click here, left click, again, left click, left click. In our spline command, we have the option to close this profile by hitting right click and close spline. But for now, let's retain this as an open profile. So I'm gonna click OK. In addition, a spline is a powerful tool in creating organic geometries. Going to this line segments highlighted in green, these are called Bezier handle. The Bezier handle gives us the option to further refine our spline form. If I click this endpoint and drag this, notice that we are able to further make adjustments on the form of our spline. Also, we can add constraints to these Bezier handles. If I go over and expand our sketch palette, notice that some of the tools of my sketch palette are grayed out. I can left click anywhere in the canvas, and now our constraints are available for us to select. So going to horizontal vertical, I can select this Bezier handle and apply a vertical constraint. On a separate video, we will dive deeper into constraints. You may pause this video to further familiarize yourself with the spline. Moving forward, I'm going to hit Escape key to exit from our constraints. Let's now delete this spline and move forward to polygons. Before making a selection, I'd like to discuss first the select tool on our toolbar. So going to select, we are now given three options on how to select entities on our canvas. One is window selection. So if I pan this, I'm going to left click and drag. So everything that was previously enclosed on that rectangular selection will now be selected. So I can now press delete. I'm going to select undo, or the shortcut key, Control Z. Let's now select the second one, freeform selection. So if I left click and hold, notice my cursor, I can create a bounding entity to enclose the spline selection. I'm going to release, and now I can press delete key. Again, clicking Control Z to undo, and going back to our last select option. The last one is the paint selection. So if I left click, notice at the upper left of my cursor, a blue square appears. So I'm still holding my left mouse button. I can now drag and paint. So now I have selected all entities of this spline, and I can now release my left mouse button. Notice that it turned into blue, meaning all of my splines are now selected, and I can now press the delete key. As a personal preference, I prefer using window selection to select entities whenever I want to delete them. Going to sketch, polygon, circumscribe polygon. Let's make our first selection. Left click and slowly drag. Notice that we're now prompted to enter a value. So this value is coming from our center point to our circumference. If I click the tab key, so the number 6 denotes the sides of our polygon. So if I enter 3, notice that we are now creating a triangle. Hitting backspace, key in 5, so we're now having a pentagon. I'm gonna left click now to finish our polygon command. Middle mouse to pan. Again, going to sketch, polygon, inscribe polygon. Let's make our center point. Left click, gonna hit tab and enter 5 sides to make it also a pentagon. Left click to finish our command. I can press escape or go directly to sketch and proceed with our third polygon, edge polygon. Another quick tip, if we hover our mouse, notice that Fusion 360 automatically infer constraints. So this one is denoted by a blue color. So this one is a blue dashed line. If I go over here, another blue entity, which is a midpoint, endpoint. And notice it automatically snaps. I can remove this one and temporarily disable by pressing Control key. So notice now, if I go over our endpoint and midpoint, there's no infer constraints. But if I let go of my Control key, it is there again. So that's another quick tip. Hold our middle mouse and pan this to the left. Let's create our first edge. Left click. Move this dialog into a more clear view. Let's enter 5 edges to make this as a polygon. Press enter. So now we have our inscribed polygon. We have just discovered 3 ways on how to create polygons. Creating and forming splines. In the next lesson, we will learn more about circles, rectangles, and points. Selecting circle. Let's first proceed to 2-point circle. Selecting a plane. 2-point circle denotes the 2 points of the diameter of your circle. So if we left click here and left click here, notice that from point A to point B is the diameter of our circle. Zooming out again. Let's try to enter a value, 50, pressing enter. So that's our 2-point circle. Under select, window selection, keyboard shortcut number 1. So now I am currently in window selection mode. Left click here and drag to select, press delete. Let's go to sketch, circle, and let's proceed with 3-point circle. Click this one. This one. Let's right click, select 3-point circle. Selecting our first point and second point. Notice that it's just like 2-point circle. And with the addition of selecting a third point. So let's select our third point here. So that's 3-point circle. I'm going to press escape to exit from the circle command. Let's make another window selection. Press delete. Let's now proceed to circle and to tangent circle. Let's make a left click, and left click. Notice that nothing happened, meaning it requires 2 lines in order for us to create a circle. Hit escape to exit from the command. Going to sketch or pressing letter L. Let's create our first point here and here. Press escape. Pressing letter L again. And going back to sketch, circle, and to tangent circle. So we are now prompted to select first tangent of circle. Let's select this line. And finally this line. So notice we have created a circle tangent to 2 lines. Pressing left click. That's our 2 tangent circle. Pressing escape to exit from the command. Make a window selection, delete. Let's create 3 lines. I'm pressing letter L. The other endpoint here. Escape, letter L again. Escape, letter L again. And final point here. Pressing escape, going to sketch. Let's go to circle and 3 tangent circle. Select first tangent of circle. Let's select this one, the second one, and the third one. Notice that the circle was created in perfect tangency with our 3 lines. So that's our 3 tangent circle. Pressing escape, making a window selection, pressing delete. And finally, let's proceed with the most commonly used circle. Let's go to sketch, circle, and center diameter circle. Take note that the keyboard shortcut is letter C. Let's select this one. Let's make our first center point in our origin. Left click and drag. Let's try to enter a value, 100. Pressing enter. Enter again. Pan. Center diameter circle from now on will be your commonly used circle command. Let's delete this one using window selection. Pressing delete. Moving forward, let's now proceed to rectangle. Going to sketch, rectangle, center rectangle. Now we're prompted to select a center point. Let's select our origin, left click, drag. Let's key in a value of 50 millimeters, pressing tab, and 100 millimeters. Pressing tab again, pressing enter. For center rectangle, notice that we have two diagonal dashed lines. So these two are construction lines. Moving forward, I'm gonna hit pan, going back to sketch, rectangle. Let's select 3-point rectangle. Let's make our first point here. Left click again, and finally let's place our third corner here. I'm gonna pan. Let's do this again. First point, second point, and last point. Again, this is our 3-point rectangle. I'm gonna hit pan again. Going to sketch. Let's now select 2-point rectangle, and the shortcut key for that is letter R. Selecting 2-point rectangle, making our first point here, moving our mouse, and last point here. So that is our 2-point rectangle. Again, let's make our first corner here and here. Let's now proceed to fit, going here. Another shortcut key for this is double clicking our middle mouse anywhere in the canvas. So zooming out again in order for us to make our window selection. I'm going to press delete now. In the next lesson, we will discover points and arcs. Going to sketch, arc, 3-point arc, selecting this plane. Let's place our first point here, second point here, and the third point here. Let's do this again. Place a point here. Let's enter a value, 50 millimeters. I'm not going to be pressing enter, but I'm going to hit left click and make the final click here. Last exercise. Let's make a point here, here, and here. So that is our 3-point arc. We are still in the 3-point arc command. Instead of going to sketch, notice that we also have the 3 options here on our sketch palette. Let's select center point arc. Gonna pan. Let's place our center point here. Go to the right, left click, and left click here. So again, placing our center point here, left click here, and let's try entering a value. Let's say 180 degrees. Pressing enter. Enter. This is our center point arc. Panning to the left. Going to sketch, arc, and tangent arc. A tangent arc requires 2 points to be executed. Let's hit letter L for line tool. Let's create a line here. Escape, pressing line again. Escape, pressing line again. And now going to sketch, arc, and tangent arc. We are now prompted to select our first start point. Let's select this endpoint and this endpoint, this endpoint and this endpoint, and finally this endpoint and endpoint. That is our tangent arc. Instead of deleting, let's select pan. Let's now discover the point command. Let's go to sketch, selecting point. The point is a powerful tool in aiding us to construct geometries. A typical application of the point command is centering entities. We are still in the point command. I'm going to press letter L for line. Selecting first point. Let's make a 100 millimeter line. Pressing enter. Enter. And let's make another line. Pressing L again. This time, let's make this 50 millimeters. Now, the scenario would be, we'd like to center the midpoint of this line aligned to the midpoint of this line vertically. How do we do that? We can do that with the aid of the point command. Now, going to sketch, selecting point, moving my point to our line. Notice now that there's a triangle, meaning our point is now on our midpoint. So left click. Notice that we have a midpoint constraint. Going to our next line, going to its midpoint, left click. And finally, going to sketch palette under constraints. Let's select horizontal, vertical. Selecting this point and this point. So now, the midpoints of our two lines are vertically aligned. That is one of the powerful applications of the point command. In the next lesson, we will master sketch constraints. Take note that we are in sketch mode. I know that because I can see the symbol stop sketch. Zooming in. Let's make this vertical and this one horizontal. Going to our sketch palette, selecting horizontal, vertical. Left click, selecting this line. Now I know that this is perfect vertical position because of the vertical constraint indicated beside our line. So applying our next constraint, the horizontal, left click. So now this is also in a horizontal position. Take note of the horizontal vertical icon at the bottom right of my cursor. So I'm going to hit escape key to exit from the horizontal vertical constraint. Let's select this line and drag it, left click. I'm going to select this point and drag this. Notice, whenever I try to move this, the line is always in a vertical position. Same here with our horizontal line. Left click in our canvas to disable. Moving forward, let's focus on these two horizontal lines. Going to sketch palette, constraints. Let's now apply collinear. Selecting this first line and then the second line. Pressing escape. Notice that both of them are now collinear. So if I try to move the other line, both of them remains perfectly collinear with each other. So that is our collinear constraint. I'm going to pan and focus on these two diagonal lines. Going to sketch palette. Let's now apply parallel. Left click, selecting this line and this line. So both of them are now parallel with each other. I'm going to press escape and select this line. Notice that they are both perfectly parallel with each other. So that is our parallel constraint. Zooming out, let's make these two circles equal in diameter. So going to constraints, browsing down, selecting equal, selecting this first circle's circumference and the other one. So now they are equal in diameter. I'm going to hit escape, try to resize this. We can also delete constraints. For example, if you'd like to have both of these circles concentric with each other, I can select this constraint, left click. So now it is highlighted in blue. I can press delete key. So let's resize this one. Left click and drag to make this bigger than this other circle. So going to sketch palette, scrolling down, I'm going to hit concentric. In addition, notice that some of the items here are grayed out. This is because that my current selection is now active and the circumference of this circle has been selected. But if I left click outside on our canvas anywhere, left click here, notice that all items are now available for selection. So again, going back to concentric, selecting this circle, this one, pressing escape, and resizing our circle. So notice that they are both concentric. Left click to deselect. I'm going to select our center point and drag this. Moving forward, let's make these two lines perpendicular with each other. Question: are these lines already perpendicular? The answer would be yes. Why? Because the angle that can be projected here would be a 90 degree. So to demonstrate perpendicular constraint, let's delete these constraints. Pressing delete. Let's try to make this in a slightly diagonal, this one as well. Left click to deselect. Now going to constraints, scrolling down, selecting perpendicular, selecting this line and this line, pressing escape. So now they are perpendicular with each other. Now if we want to go back to make this horizontal and vertical, we can always go back to constraints. I'm going to left click anywhere in the canvas to deselect. Scrolling down, selecting horizontal, vertical, left click. So now I no longer need to apply a vertical constraint here because it is already perpendicular. So obviously this one is in a perfect vertical position. Our horizontal vertical constraint is still active. I can opt not to press escape key. Let's go to sketch palette and select tangent. So now we're in tangent constraint, selecting this line and the circle, pressing escape to disable, So let's select the center point and try to drag our circle. So that is our tangent constraint. Middle mouse to pan. Let's apply symmetry to these three lines. So going to constraints, scrolling down, left click to deselect, going to symmetry, selecting this line and this line, and the middle line would be our mirror plane. So selecting this one, and now the symmetry constraint is now applied to the three of them. I'm going to press escape. I'm going to drag this one. Notice that they are both equal in direction to our middle line. So that is symmetric constraint. Notice that this line is currently selected because some of the items here are grayed out. So left click to deselect. Let's pan. Go to constraints. Select smooth. So selecting this spline and this line. So now they are in smooth transition. So that is our smooth constraint. In the next lesson, we will learn sketch dimensions and editing sketch geometries. Let's open up 12, editing sketch. Notice that we have a 3D model here. In our past videos, we discussed about anticipating changes. So the scenario would be, we will add dimensions to our 3D model. Now to do that, we have to go back to Sketch. So I'm going here in our timeline. Double click or right click. Edit Sketch. So now we're in our sketch mode. Examining our 2D sketch, notice that we have some constraints. And our model is definitely not fully defined. I know that because I don't see any dimensions. Dimension is a commonly used tool. So going to Sketch, going down, Sketch Dimension. Take note that the shortcut key for this is letter D. Now because this is a commonly used tool, let's add this to our toolbar. Left click. So now it's in our toolbar. Pressing D or selecting Sketch Dimension, left click. So notice that my cursor now turned into black, and beside our cursor there's a sketch dimension symbol. First, let's add the distance between this center point and this center point. So going over, let's hover our mouse to the center point. Again, notice that it turned into white, meaning I can left click that entity. So again, moving to that entity, left click. Moving downward, let's left click this center point that is aligned in our origin. And slowly moving our mouse to the left, positioning our dimension. Let's left click here to place our dimension. Notice that the items are highlighted in blue. So I can now key in 75 millimeters and press enter. Take note of our cursor. Notice that we are still in the sketch dimension mode. Let's add a diameter for the circle. So now it is in white color. Left click and move our mouse. Left click again. Our intent is the diameter of this circle to be in 30 millimeters. So it's now in 30. Let's press enter. Now there are some instances that you prefer our dimension to be in radius. So I'm gonna select escape, selecting our dimension, right click, and toggle radius. So notice it is now in radius mode. Moving forward, I'm gonna hit letter D to be in dimension mode. Let's add a diameter here for the circle. So it should be 15. Next, let's add a diameter here again to be 30. Keying in 30, enter. Let's try to add constraint. I'm gonna hit escape. I'd like this circle and this circle to be equal in diameter. Now this one, we have fully defined this one to be in 15 millimeters in diameter. Going to constraints, scrolling down, selecting equal. It's now in white color, left click and left click this one. So notice that there's a equal symbol. Gonna select escape and press letter D again for sketch dimension. Let's now add a radius for this fillet. So selecting this one and moving our cursor. So let's drop it here or here. Keying in 10 millimeters, pressing enter. Moving forward, next, we'd like to define the length of this diagonal line. So I'm going to left click and drag our cursor to the right. Notice that it gave us a different dimension, a vertical one. And again, going back and moving downward, it gave us a horizontal dimension. But notice again slowly, as I go back to our diagonal line, notice that my cursor will change in appearance. So it now turned into white. So in that mode, I can make a second left click, let's say somewhere here, and now it turned into a black color in sketch dimension. And notice if I move my mouse, it now gave us the diagonal dimension. So moving our mouse again, let's place our dimension somewhere here and keying in 95 millimeters, pressing enter. Next, let's add an angle between these two lines. So still in sketch dimension mode, I can left click this one, left click again, and now we're given an angle. So moving our cursor and let's position this here and keying in a value of 60 degrees, pressing enter. Because Fusion knows we're in the angular mode, notice that a while ago I only entered 60 for our angular dimension. If we'd like to change the values of our dimensions, we can always go over to that dimension and double click. So I'm pressing escape. Again, I can double click this one and enter a new diameter. A quick tip, we can also do mathematical calculations in the dimension dialog. So if I double click 75 again, I can key in 80 minus 5 and press enter. So notice that it gave me a quick calculation. We can also do multiplication, division, addition, and subtraction. So moving forward, I'm gonna pan. Notice that the circle and the circle is not concentric. So moving forward, I can go to constraints, selecting concentric, selecting this one and this one. Again, pressing letter D. Let's add a diameter for this one. I'm gonna place it here and key in a value of 60 millimeters, pressing enter. And for this circle, left click, I'm gonna key in 20 millimeters. I'm gonna press escape and left click this one to position this. So zooming out. Now we can go to stop sketch, going to home view, and that is how to edit sketches and place dimensions. In the next video, we'll discover quick shape section. Let's start with box. I'm going to create and select box. So now we're prompted to select a plane. I'm going to select the XZ plane and just create a quick rectangle. No need to have a specific dimensions for now. So I'm going to left click the final end of our rectangle. I'm going to pan, and we can drag this arrow to indicate our height, the box height. Also, we can input here specifically the length, the width, and the height. I'm going to click OK now. So I'm going to pan. Moving forward, let's go to create cylinder. So again, we're prompted to select a plane. I'm going to select the XZ plane again, and let's make a quick cylinder here and drag this for our height. So we can enter the diameter here or the height. I'm going to press OK. I'm going to pan. Next is the sphere. So again, we're prompted for a plane, selecting this one, and now we're prompted to draw a point. So left click, and we can now drag this arrow to indicate our diameter. So I'm going to press OK again. I'm going to pan. Next is the torus, going to create, selecting torus. Now we're prompted to select a plane. I can go here, left click, and select the XZ plane. Left click, and placing our center point, moving our cursor, just an eyeball, left click again, and now we have our torus. We can specify our inner diameter and the torus diameter. I'm going to press OK. I'm going to pan. Moving forward, going to create coil. Now we're prompted to select a planar face. Let's select the XZ plane. Place our center point here and create our circle. Zooming out. So now we have a coil. The coil has different types. It can be via revolution and height, revolution and pitch, height and pitch, and spiral. So here we can reorient the orientation, specify a specific diameter, let's say 150 revolutions, let's say 2. I'm going to press tab, let's say 150, and let's say the angle is 45 degrees. Let's revert back to 0. Also, we can change the profile section. Now we are in circular, we can go into square and triangular. And we can also indicate the section size. Going back to circular. So that is our coil. Pressing OK. And finally, going to create, we have pipe. Now a pipe requires a path. We can create the path by creating a sketch. I'm gonna hit cancel. So under sketch, let's sketch on the XZ plane. Left click. So I'm gonna pan. Let's create our spline here as a path. Going to sketch. Again, I'm in the line tool. I'm gonna go to spline. So let's make our first point here. Just an eyeball. And right click. Hit OK. So we're done sketching. We can now proceed to stop sketch. I'm gonna pan. Go back to create pipe. And now we're prompted to select a path. Now the path would be this spline. So left click. So now we have a pipe. So we can indicate the distance and indicate the section too. Circular or triangular. And we can indicate the section size. Also, we can opt to make it a hollow. I'm going to zoom in. Or not a hollow pipe. So that is our primitives in Fusion 360. In the next lesson, we'll discover how to create a revolved feature. Creating a revolved feature, it requires us a close sketch profile. Going to sketch, let's create a line. I'm going to press letter L. Select this plane, left click. Let's make our first point in the origin. Left click. Key in a value of 150 millimeters. Pressing enter. Left click. Key in 20 millimeters. Enter. Left click. And finally, for this vertical line, 20 millimeters. Enter. Left click. I'm going to press escape. Going to sketch. Let's make a spline. Zooming out. Make our first point here. Left click. No need to be exact. You may just do an eyeball. Right click and select OK. I'm going to press letter L to create a line. Left click here and connect it to the endpoint of our spline. I'm going to press escape. Going to sketch palette, constraints. I'm going to select horizontal, vertical. Let's apply a horizontal constraint. Press escape. Again, going to constraints. Let's select smooth. Select this spline and this line. So now we have a smooth constraint. Go to zoom out, hit escape, and select the points of our spline to further enhance the form of our spline. So we're gonna hit stop sketch, go to isometric view, go to create, select revolve. So now it requires us a profile. Left click to select for an axis. I'm going to select our y-axis. Again, left click. So we can make a partial revolution by selecting this ball handle. I'm going to go back to angle and key in 360. I'm going to press enter. And now we have a revolve feature. The next lesson we'll discover how to create a sweep feature. So let's open our exercise file. As you can see in our timeline, we have two sketches, a path, and a profile. So going to create sweep, and let's first discover single path. Now we're prompted for a profile. Let's zoom in. Left click to select this one. So now it is selected. And for the path, left click, zooming out. Let's select this as our path. Hit OK. So now we have a swept profile. Again, going back to our timeline, double click to edit feature. Let's go to the other type, which is path and guide rail. I'm going to deselect everything. So for our profile, let's select this one, left click. For our path, left click to activate and select this one as our path. And for our guide rail, let's select this spline. So as you can see, this is the end result of the sweep feature under the type of path plus guide rail. Like revolve and sweep, loft also requires closed profile sketches. So before grabbing the tool, first let's create a sketch. I'm going to create a circle, center diameter circle, create it on the XZ plane, left click, let's say 50 millimeters, pressing enter. Going to stop sketch. I'm going to go to construct, going to isometric view, zooming out. I'm going to select our XZ plane. I'm going to grab this arrow and key in a value of 100 millimeters. Pressing enter. Double click middle mouse to zoom extents. Let's create a sketch on our new plane. Left click to select, right click to create a new sketch. So going to sketch, let's select circumscribe polygon. I'm going to pan. Select the origin as our center point and slowly drag. Let's key in a value of 35 millimeters. Pressing tab. Let's make our polygon having 3 sides, meaning it's a triangle. I'm going to press enter. Going to stop sketch, zooming out, going to create and selecting loft. For our first profile, let's select our triangle, and then for the second one is our circle. So notice the transition between the two geometries. So that is loft feature. We can also add in some additional rails and guide type, or make it a closed entity. But basically, the loft creates a smooth transition between two different varying entities. So for our example, it was a triangle going into a circle. I'm going to press OK. Ladies and gentlemen, that was sweep and loft. In the next lesson, we will discover how to create a rib and a web. We have here an L-shaped model. Our intent is to place a rib in the middle. The rib uses an open sketch curve to create a thin feature, and the rib is created planar to the sketch plane. Let's create a sketch in the middle of this model. I'm going to press letter L for line. I'm going to select this plane, left click, and place our first point here. And somewhere here. No need to be exact for now. So I'm going to go to stop sketch, isometric view, zoom out. I'm going to create rib. So it prompts us to select a curve. My curve would be this line, left click. Take note, the rib is in symmetric option, so we can drag this blue arrow to define the thickness, or key in a value of 10 millimeters. Pressing enter. So that is the rib feature. The web feature also requires a sketch. So we have here a simple open box. Let's create a sketch within this height. So I'm going to go to construct, offset plane, left click. Let's select the bottom surface of our box, left click, orbit, drag this blue arrow. I'm going to key in -50. Pressing enter. So now we have a plane. We can left click that one. So now it is selected, right click and create sketch. So we're going to press letter L for line. Let's create a line at this endpoint. Left click and connect it to the other side. Left click. Pressing escape key and pressing letter L again. Left click here and final point here. Gonna press escape. Gonna go to stop sketch. Gonna pan. Under create, gonna select web. So it prompts us for a curve. So I'm gonna orbit, shift, and middle mouse, holding them both. Left click this one. I'm gonna press Control to click this other line. And now we can drag this blue arrow. So notice, it created a web. So I'm gonna key in a value of 10. I'm going to press OK. So this is the web feature. In the next lesson, we will discover how to create a hole and a thread. We have here a box primitive and a sketch on that box. So the sketch has points, 4 points. I'm going to go to stop sketch, isometric view, Going to create hole. Take note, the shortcut key is letter H. Left click. Now we are prompted to select a face, plane, or a sketch point to locate our hole. Let's move our cursor on the top surface of our box and left click. So I'm going to go to top view, left click. In addition, we can move our hole's location via dragging this blue circle. So if I left click and drag, I can position this one anywhere on our top side of our box. So notice if I drag this, it automatically snaps to the center of our box. In addition, we can also grab this bracket looking symbol to resize our hole. Let's key in a value of 20 millimeters for the diameter. Pressing enter. Going to isometric view. And now we have a hole. Going back to our hole feature, I can go to our timeline, double left click. And there's our dialog box. So we have hole types like simple one, counterbore, countersink. And for our hole, we made it to extend up to all. I'm going to press OK and press letter H to create another hole. But this time our placement would be coming from a sketch. So left click to select. Now we're prompted to select a face or point. I'm going to orbit. Going to go to the browser and unhide our sketch. So now we can select a point. So I'm going to left click this one. Left click, left click, left click. Let's resize the diameter of our hole to be, let's say 10. Let's make it a counter bore. And the diameter would be 15. Zooming in. Let's key in a value of 3 millimeters to our counter bore depth. I'm going to press tab. What extents mean is, for our option, which is all, it means make the hole that will extend all the way. So we can also change this one to 2, meaning up to here. Let's select this face. And we can also modify the angle tip. Let's say 90 degree. So notice the angle changed. So I'm going to go back to extends all and press OK. I'm going to turn off our sketch. So that is whole using sketch. Moving forward, let's create a thread on our simple hole. I'm going to move our timeline marker so that our thread feature will happen before our sketched holes. So going to create, selecting thread. Now I'm prompted to select a face. I'm going to select this face. I'm going to orbit. So we can go for an option if it's going to be full length or partial one. Let's say 20 millimeters. So notice the thread is now only 20 millimeters. We have options for various thread types. We can assign designation, assign a class, and the direction. We also have the option if you want Fusion 360 to remember the thread. In addition, the thread that we have created is just a graphical representation. We can have this fully modeled by selecting this one, but the best practice would be deselecting this, as this option will consume more file size. So that is our thread. I'm going to press OK. In the next lesson, we'll be learning more about patterns. Create pattern, rectangular pattern. All patterns can be applied to faces, bodies, features, and components. Again, those patterns can be rectangular, circular, and pattern on a path. For now, we will apply a rectangular pattern to a feature. Here we have a rectangular board, and we'd like to pattern this hexagonal cut. Remember, our timeline stores the list of our features. Now we are prompted to select a feature. I can hover my mouse over the timeline and select this extrude to, which is our hexagonal cut. So left click. So now it is selected, and we can now indicate the directions. So left click. Directions can be indicated by selecting an axis or a straight edge. So for now, let's select this axis. I'm going to go to top view. And let's slowly adjust our rectangular pattern. So dragging this blue arrow. Notice we have check marks. So I can deselect this one if I don't want the feature to be made here. So I'm going to hit OK. So notice we don't have a pattern here. So this is our rectangular pattern. I'm going to move our timeline marker to suppress our rectangular pattern. I'm going to go to Sketch, Polygon, Circumscribe Polygon. Select the surface of our board. Left click. I'm going to pan. And hover our cursor in the origin to infer a constraint. So slowly going down. And let's make an eyeball and create the polygon here in the middle. So left click. I'm going to key in 20 millimeters, and it's a hexagon, so number 6, key in 6. Pressing enter. I'm going to go to stop sketch, isometric view. Going to create, extrude, and select our sketched hexagon. Left click. So drag the arrow downward and the extents. Make it all. Hit OK. Zoom out. Going back to create. Pattern. Circular pattern. Now the object, specifically the feature we'd like to pattern is this one. Left click. Now it is selected. Left click to activate axis. And let's select our Y axis. So left click. I can drag this handle to add or decrease the quantity of our pattern. So I'm gonna key in 5. I press OK. So now we have a circular pattern. I'm gonna click and drag our marker before extrude 3. I'm gonna unhide sketch 5 and proceed to create pattern, pattern on path. So the object again would be this feature. Going to timeline, left click. For path, left click to activate and select our sketch spline. So left click. I can select this blue arrow and drag. Let's key in a quantity of, let's say 8. Again, going back to the arrow and dragging it. So notice the distance between our pattern expands. Let's key in 1500 millimeters and add additional 2, making it 10. I'm going to press OK. So now we have a pattern indicated by a path. In the next lesson, we'll be discovering the mirror and thicken tool. Cover plate, sketched in half. We know the final part will be symmetrical, and to do that, we will apply the mirror tool. Going to our timeline, double click to edit our sketch. Here we will use the mirror tool in sketch mode. So going to sketch, going to mirror, zooming out. I'm going to create a window selection. Our mirror line will be this line. So definitely it is now selected. So I'm going to hover again. I'm going to press Ctrl and left click to deselect. As you can see, it's now 21. Moving forward, let's now select mirror line, left click to activate, and selecting this line. Left click. So now it is mirrored. So I'm going to press OK. I'm going to stop sketch, isometric view. I'm going to press letter E for extrude, and now we can extrude both of these regions into one. So hit Control, left click, so it's now 2. I'm going to drag this one, make the distance to 0.2, and now we have a symmetrical part, and the mirror line is this line. To demonstrate the mirror tool under Create, I'm going to go back to our timeline, double click to edit sketch. I'm going to go to sketch, select trim, zoom out, holding my left click to delete these items. I'm going to go back to stop sketch, isometric view. And now finally we have the half of the cover plate. So again, going to create, mirror, and now the pattern type would be body. So selecting this body, left click, and the mirror plane, left click. So our mirror plane will be this plane. Left click to select and hit OK. So this is the other way to create this part using mirror tool. Moving forward, let's now proceed to the thicken tool. The best way to demonstrate the thicken tool would be creating a surface extrusion. But first, let's create a sketch. So I'm going to sketch. I'm going to press letter L for line. Select this plane. Left click. Enter 50. Pressing enter. Left click. I'm going to press escape. Press letter L again. Left click. Key in 50. And left click again. I'm going to press escape. Stop sketch. Now, going to our main toolbar, under model, left click. Let's now move to patch. So under create, let's select extrude. The good thing about patch mode is that we can extrude entities that doesn't have a closed loop profile. So let's select this line and key in 40. The direction is symmetric. I'm gonna hit OK. Now the body went missing. I can go over to bodies and check it. So as you can see, the bulb was turned off. Turning it on. Again, going back to patch, model, going to create, thicken, and now we can finally select these two faces. Left click to select this one. I'm going to hit Control, left click, specify our thickness, and let's just key in a value of -10 millimeters. Pressing enter. So that is our thicken tool. In the next lesson, we'll discover the fillet and chamfer tool. A simple box to demonstrate fillet. Under create, I'm going to select box. Selecting this plane, I'm going to place our first corner in the origin. I'm going to key in 100, press tab 100. Pressing enter and enter again. And for the height, let's key in 60 and hit OK. Going back to home view, zooming out, going to modify, selecting fillet. Take note, the shortcut key for fillet is letter F. Left click. And now we are prompted to select edges to fillet. Left click to select this edge. I'm going to hit Control, left click and rotate. Hitting Control again and left click. And finally this last edge, Control left click. Let's key in a value of 5 millimeters. I'm going to press tab. And now, as you can see, the four corners of this box now has a fillet. Notice that the fillet command is still active. I'm going to expand selections. Take note that we have a first edge sets with a radius of 5 millimeters. So the first edge sets are these four edges with fillets. We can have another selection by hitting the plus button. Now we are prompted to select a new set of edges for our new edge sets. I'm gonna left click this one, left click, left click, and left click. So for our second selection sets, we have this 4 edges on top. Let's key in a value of 10 millimeters. So now it automatically applied the fillet with a value of 10 millimeters. I'm gonna press tab. For fillet, we have the option to select a chord length type. I'm gonna revert back to constant radius. G2 refers to continuity in terms of radius curvature. Notice the slight difference. Also, we have the option for corner type, which is setback, and rolling ball. That is our fillet command, and now I'm going to press OK. In addition, if we select an edge and right click, the marking menu automatically provides us the option for fillet and chamfer command. Moving forward, let's head towards our timeline. Grab our marker and move it to the left before our fillet. Next, let's now head to Modify, Chamfer. A chamfer applies a bevel to one or more edges. Let's now select chamfer. So now we are prompted to select an edge. For our first edge, I'm going to select this one. Left click and click a value of 10 millimeters. I'm going to press tab. I'm going to hold control. Left click this one. I'm still holding control. Left click and left click. We have 3 options for chamfer type, and currently we are under equal distance. Let's now select 2 distances and go to top view. For our vertical distance, let's key in a value of 20 millimeters. For our horizontal, let's key in a value of 30 millimeters. Ladies and gentlemen, that is chamfer type under 2 distances. And finally, let's move over to chamfer type distance and angle. For the angle, let's key in a value of 45 degrees. Also, we have the option to grab our blue dot to adjust the angle. I'm going to leave it at 45. For distance, let's say 30 millimeters. I'm going to hit OK, going to home view. And finally, that is our chamfer command. In the next lesson, we'll discover the shell, draft, and scale operation. Shell. A shell removes material from a part interior, creating a hollow cavity with walls of a specified thickness. To demonstrate, let's now go to Create and create a box. I'm gonna select this plane, left click on the origin, key in a value of 100, press tab, 100, and press enter, enter. Let's make the height 60 millimeters and press OK. Panning. Going to Modify, selecting Shell. Now it prompts us to select a face or a body. First, let's make this box hollow. Select this body, left click, and key in a value of 5 millimeters. Going to press OK. So now definitely this box is hollow. To prove that, I can go to Inspect, Section Analysis, Now we are prompted to select a face. Let's select our right face and drag our arrow. Notice that the box is hollow inside. Gonna press cancel. Go into our timeline, double click. I'm gonna deselect. Leave the tangent chain active. So for direction, we have inside, outside, and both. Let's use inside. And now let's select the top face. Left click. Let's modify our thickness to be 10 millimeters. Hitting Control and left click. Notice it removed this face. Again, I'm gonna press Control. Moving over to this side, Control and left click. And now we have removed 3 faces. That is our shell command. I'm gonna press OK. Moving forward, let's now proceed to our second modifying tool, which is the draft. The draft applies a draft angle to a specified planar faces. To demonstrate, I'm going to go back to our timeline. Double left click. I'm going to hit Control. Left click this face and left click this face. And press OK. Let's assume this box is a plastic case for plastic injection. Going to Modify. Going to Draft. Now we are prompted to select our base plane. Let's say that our parting line is in this plane. I'm going to select this one. Left click. And for the faces that will be having a draft angle, let's select this face. I'm going to hit Control, left click. I'm going to rotate, left click and left click. And say the angle of our draft is 5 degrees. I'm going to go to Top View. Notice the addition of 5-degree angle to our surfaces. Take note, if I revert back to 0, notice the draft disappeared. So again, let's key in 5. And there it is again. Going back to isometric view. We can also flip direction. If this part is really for plastic injection, then we need to add a draft angle also on the outer faces. So again, selecting Control, left click, rotate, left click, going to our top view. Notice the outer surfaces with draft angles. Going back to isometric view, and now I can click OK. That is our draft modifying tool. And finally, let's proceed to Scale Modify tool. Under Modify, Scale. So the Scale command is simple and straightforward. Now we are prompted to select an entity. Selecting this body, left click. And for our point, left click. Let's expand the origin folder and click our origin point, left click. Enter a value of 2 for scale factor. Hit OK. Now we have scaled our model to 200%. That is our scale tool. In the next lesson, we'll discover the modify tools combine, replace face, and split face. Combine, which performs Boolean operations between solid bodies. Left click. We have two bodies here, body 3 and body 7. So for our target body, let's select body 3, which is this one. Left click, and the tool body to be body 7. Left click. For the operation, let's select join, and we'll leave the new component unchecked and the keep tools unchecked. Hitting OK. So now we have turned two bodies into one. Let's add a quick fillet. I'm going to press letter F, select this edge, and key in a value of 5 millimeters. I'm going to hit OK. Going to front view. So ladies and gentlemen, this is the combine tool. Allow me to demonstrate replace face. Let's create a box. Select this plane. First click on our origin. I'm going to key in 70. Pressing tab 70. Press enter. Enter. And for the height, let's make it 70. I'm going to hit OK. Going back to home view. Let's do a sketch. Going to sketch. I'm going to select spline. For the planar face, let's select this one. Left click. No need to be exact. I'm going to place our first point here, 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 and finally here. Right click and hit OK. I'm going to go to stop sketch. Moving into a different workspace and selecting patch. Going to create, selecting extrude. Now for the profile, I'm going to select the spline. I'm going to grab our arrow to change the direction. For the extents, I'm going to select 2 and make it up to here on this side. I'm going to hit OK. Going back to model workspace. Going to modify, selecting replace face. For the source face, I'm going to select the top face. Left click. And for the target face is our extruded spline. Left click to select. And finally hit OK. So going to our browser, I'm going to turn off the visibility of body 2. There you have it, our replace face tool. Under new design from file, open up 22splitface.f3d. We have here a mouse under development. So here I created a sketch and extruded it sideward. And above it, I created a plane. And on that plane, I created a sketch. And that sketch, I extruded it under the patch workspace as a surface. Going to modify, selecting split face. For the faces to split, I'm going to select this face. For our splitting tool, left click to activate. I'm going to expand our bodies folder. I'm going to select body 10. And I'm going to extend our splitting tool. Left click to select and hit OK. Going to patch workspace. I'm going to rotate. I'm going to go to create, selecting patch. For the selection, I'm going to select these edges. Left click. And I'm gonna make sure that enable chaining is unchecked. So selecting here, I'm not pressing Control key. I'm just doing a left click, selecting this one, this one, this one, this one, and finally this one. So notice the change of color, meaning it can now be a patch. I'm gonna hit OK. Going back to Model Workspace, under Create, I'm going to select Thicken. For the faces, I'm going to select Body 15. Left click. For the thickness, I'm going to key in 2 millimeters. And finally hit OK. I'm going to hide Body 1. And from here, I can right click and create component from bodies. So there you have it. That is the split face command. In the next lesson, we'll learn how to split a body. Going to modify, split body. A typical application for split body is for plastic parts. For example, TV remote controls, your cell phones. Those are initially made as one part and then split. To demonstrate, let's go to Sketch, Center Rectangle, selecting this plane. I'm gonna pan. For our center point, let's select our origin. I'm gonna key in 70, pressing tab, 150. Gonna press enter, enter. I'm gonna extrude, and the shortcut key for that is letter E, pressing letter E. Selecting this profile, left click. Let's make the direction symmetric. I'm gonna drag this upward and key in a value of 25 and press OK. Going to browser, expanding bodies. Notice that we have one body, which is body 3. We can now go to modify, split body. Now the body to split is body 3, this one. Left click. Let's leave extend splitting tool checked. For our splitting tool, I'm going to left click to activate. Going to our browser and selecting our XZ plane. Left click to select. Take note of the reddish extension of our splitting tool. I'm going to hit OK. Going back to our browser, notice that we now have two bodies, body 3 and body 5. If this were a plastic part, my parting line would be here. If I hide body 5, I can now go to modify, apply a draft, and then apply a shell. Ladies and gentlemen, that is our split body modifying tool. In the next lesson, we'll discover T-splines and the sculpt environment. In the past, T-splines was commonly popular with Rhino. But in year 2011, Autodesk purchased T-splines. Now, the transaction strengthened the freeform surface modeling capabilities of its manufacturing segment. So a T-spline is a CAD technology that helps designers create smooth, high-quality models and quickly achieve the right look and feel. One of the great things about T-splines is its compatibility with existing modeling techniques, and it integrates easily with most production pipelines. So moving forward, another cool thing about T-splines is when compared to NURBS, notice that this T-spline car has a fewer control points, which is about 50%. NURBS, otherwise known as non-uniform rational basis spline, is a relatively old technology which was invented in the 1970s. On the other hand, T-splines was recently invented in the year 2003, and both are two different ways to represent smooth computer-aided design models. In addition, T-splines is an extension of NURBS. Now, if you are wondering why letter T, notice that the control net at a terminated row resembles the letter T. In T-splines, control points can be connected to 4, 3, 5, 6, or more other points. And commonly, these points are called star points. And this ability to have star points is a fundamental difference between T-splines and NURBS surfaces. Another key point for star points is the G1 tangent continuous surface near the star point. Also, star point needs to be 3 edges apart. So if we are going to have another star point, it should be 1, 2, 3, and somewhere here would be our next star point. Also, star points can be refined. Another cool thing with T-splines. And finally, a good advice is do not have T connections close to star points. So in other words, if we add another point here and here, so this one is a bad practice and should be avoided. Here are the golden rules for modeling with T-splines. Number 1 is to pay attention to the flow of CVs. So CVs, I'm going to go to Edit Form and go to Selection and Filter Vertex. So these are the CVs. Control vertices. In this model, the flow of CVs here is this edge. And if this were a car, you have to take note of the flow and alignment of your CVs. For number 2, place CVs together for a tight curvature. Notice in this feature, we have a closer CVs compared to the rest. This is to achieve the rounded edge detail. For minimum number of CVs, make it a habit to keep it at a minimum, and unless needed for a certain detail, like this one, so that is the only point that we will add CVs. Less CVs, less complexity. Aim to use 4-sided face. So the 4-sided face pertains to this one, 2, 3, and 4. Although we can get away with T connections like this one and star points here, 4-sided face are a good foundation. That is why aiming for a 4-sided face is always a must. Items 1 to 4 are similarities to NURBS. Star points are not necessarily 5 points, so here we have a 3. They are multi-points transitioning into a star form. So if we have a 4-sided face, a star point will definitely be a transitioning aid. And at times, it is also recommended to be in a flat surface, similar to a C-pillar for a car. Next one is proportion first before details. For this knife handle, this was initially created as a rectangular box. and I drag this portion to be at an angle, and on the latter portion I added tighter CVs to create details. Number 7, star points change direction. Taking a look at the end of our knife handle, here we can notice the transition into a curve. Take note, the occurrence of a star point is an indication of a possible change in direction. Items 5, 6, and 7 are polygonal behavior. And for the last one, T-points transition detailed areas. For our knife, let's say here, this bump would not be passable if we did not apply a T connection. So if I deleted this edge, this bump would not be created. In conjunction to the golden rules 1 to 7, T connections are very unique in a way that it blends out nicely in the transition for detailed areas. In the next lesson, we'll be creating T-spline primitives, namely box, plane, and cylinder. You may be wondering, where is the sculpt environment? You can access that by going to Create Form. I'm going to hit OK. Now we're in the sculpt workspace. For our first primitive in our sculpt workspace, let's discover box. I'm going to create, selecting box. Now we are prompted to select a plane. I'm going to select our XZ plane. Left click. We have two types of rectangle. It can be center or 2-point. I'm going to select the center type. And for our center point, let's select our origin. Left click. And slowly drag. I'm going to key in a value of 60. Hit tab and 100. I'm going to press tab and pressing enter. So now we have our dialog box. Here we have the option to modify our length, our width. Going back to our 3D model, I'm going to zoom in and pan. Notice these three handles. These are sliders which we can use to adjust the number of faces. If I left click and drag, notice that I am adding additional 4 faces. Let's try this one. Left click. Notice the addition of new faces. Also this one. Left click. Going back to our dialog box, I'm gonna key in 3. The width faces to be 3. The height faces to be 3. For the height, we can drag this handle upwards. I'm gonna key in a value of 50. For the direction, let's leave this on this side. Also, we can add symmetry, or we can do mirror. I'm gonna go to fit to have a good view. Again, going back to symmetry, we have the options for length, width, and height. I'm gonna uncheck width and height. And finally, length. Take note that symmetry can also be applied after creating the box by going to our toolbar and selecting symmetry. I'm going to press OK. So now we have our primitive box. A very important tip. Take note that if you are creating primitives, it is a very good practice to have the faces be kept at the minimum. Apply faces only when adding new geometries. Moving forward, I'm going to click Finish Form. Notice that I am not in the sculpt environment anymore. To re-access my model and do some revisions, I can go back to our timeline, double click or right click. I'm going to double click. I'm going to hit OK. So now we are in the sculpt workspace and can do additional changes. Going back to Finish Form. Moving forward, going to Sculpt Workspace, Create Form, hit OK. Going to Create, selecting Plane, left click. For our planar face, let's select XZ, left click. I'm gonna pan. Specify our first center point. Also, we have the option to select 2 point. I'm going to go back to center. Left click here. Key in a value of 50. Pressing tab. 50. Left click. Again, we have the option to drag our slider to add faces. And to drag our arrows to modify our length and width. I'm going to press OK. Finish form. Going back to create form. Removing this dialog box permanently. Pressing OK. Going to create. Selecting cylinder. Selecting our XZ plane. Left click. I'm going to pan. Now we are prompted to select our center point. Left click. Specifying our diameter. Let's key in a value of 50. I'm going to left click. So now we have a cylindrical form. Again, we can drag the arrow upwards to adjust the height. This arrow to adjust the diameter. And the sliders to adjust the faces. I'm going to click OK. Going to Finish Form. Double click my middle mouse. That is our box, plane, and cylinder in the Sculpt workspace. In the next lesson, we'll discover sphere, torus, quad ball, and pipe. Going to Create Form, under Create. Let's select Sphere. Left click. For our plane, let's select XZ. For our center point, let's select our origin. Left click. Here we are given 2 sliders to adjust our longitude faces and latitude faces. I can drag our blue arrow to specify our diameter. I'm going to hit OK. So now we have a sphere. I'm going to go to Finish Form. Next is torus. I'm going to go to Create Form. Under Create, torus. Specifying a plane, left click. I'm going to pan. Specify our center point here, left click. and slowly move our cursor. Let's key in a value of 150. I'm going to left click. So now we have a halo, in other words, a torus. I'm going to move this one. Let's specify a diameter. Let's revise it to 100. For diameter 2, let's key in 25. And hit OK. Going to finish form. Now we have a torus. Going back to create form, under create, let's select quad ball. For our planar face, let's select XZ. I'm gonna pan. Specify our center point here. The difference between the quad ball and the sphere. Notice for quad ball, we only have a one slider to adjust the span faces. I'm going to drag our arrow to adjust the diameter and hit OK. Going to finish form. Now we have a quad ball. We're going to fit them all into view. Take note of the difference between the two. Moving forward, let's create a freeform pipe. Going to create form. Under create, let's select pipe. A pipe requires a path, so we need a sketch to create a path. Going to sketch, let's make the path a spline. Let's select spline. For the plane, let's select this plane. For our first point, let's have it here. Left click. Here, 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 and finally select create and continue. Left click. I can go to stop sketch or immediately proceed to create and select pipe. So now we have a path. I'm going to select this path. You may be surprised that this is not a pipe looking object. To resolve that, we can go to display mode and select smooth display to make it rounded. In the later chapters, we'll discover what display mode is. For now, let's select smooth display. Although we have just one entity, which is a spline, let's leave chain selection checked. For global diameter, let's leave it as 20. For section, left click. Notice that if I hover my mouse on the spline, there's a red dot trailing. Take note, if I left click, it adds additional segment. Again, I'm gonna left click to add another segment. That is what section is. Also, let's leave display curve splits unchecked. For end types, we have the option to make it open, square, or a spike. Let's select square. Notice that both of our end types turned into a square. I'm going to select another handle. Going to select this one. Notice there's a drop down for end type. I'm going to select spike. That is how we modify the end type. I'm going to orbit. For segments, notice that there are 3 dots, indicating that indeed we have 3 segments. If I left click this dot, now we are given a slider. We can now adjust the number of segments for this area. Again, selecting this dot, moving our slider to adjust the segments. So dear friends, this is our pipe in the sculpt environment. In the next lesson, we'll discover the types of display mode. And let's create a simple box. Left click. For the plane, selecting XZ. I'm on the center rectangle type, specifying center point at the origin. And let's create a 100 by 100 box. I'm gonna left click. I'm gonna pan. And I'm going to accept the default value for height, which is 50 millimeters. And press OK. In the sculpt environment, we have 3 ways to display a T-spline body. Currently, we are viewing this T-spline body in smooth display mode. Now, take note, if I press Alt-1 on my keyboard, notice that it went into box display mode. So that is Alt-1. Now if I press Alt-2, now we are in a control frame mode. Now if we want to go back to smooth mode, we can press Alt-3. Again, Alt-1 is box mode. Alt-2 is control frame mode. And Alt-3 is smooth mode. As we go on and create a more detailed and complex T-spline bodies, we may have the tendency to overlap those faces. And overlapping faces creates errors in our model. Now if that occurs, Fusion 360 will not be able to convert those bodies into solids. Now to demonstrate that, I'm going to right click, edit form. I'm going to select this face, left click. I'm going to pan. I'm going to left click this arrow. Now it turned into blue. I'm going to press Alt and left click at the same time and drag upwards. Notice I added a new material. I'm going to press Alt and left click again, holding them both, and drag upwards. Again, we added a new material. Now I'm going to drag this arrow by left clicking only. Left clicking anywhere in the blank space to deselect. I'm going to press Alt-1. So now we are in box mode. I'm going to select this edge and select this arrow. Left click and drag. Take note that now we have an overlapping face. And now if I click finish form, notice that an error have occurred. This is because we have an overlapping or self-intersecting face. A good practice is to cycle through these different display modes as you go on and sculpt your T-spline bodies. I'm going to hit return, hit close, I'm going to press Ctrl Z and hit Alt 2 and Alt 3. Another way to access display modes is going to Modify, Performance, Display Mode. I can select Box Display Mode, Control Frame Display, and finally Smooth Display. Dear friends, this is the importance of cycling through the different display modes. The next lesson we'll discover the manipulator. We saw a glimpse of the manipulator. Now, what's the manipulator? Let's go to our toolbar, create form, and let's create a simple box. Select this plane, selecting the origin, key in 100 and press tab 100, enter. So now we have a T-spline box. In the Sculpt workspace, the most common tool that we'll be using is the Edit Form. I can access it through Modify, Edit Form, or we can right-click and select Edit Form. Selecting Edit Form, under Edit Form, we now have the option to select Vertex, Edge, or Face. And we can do an extrusion if we press the Alt key. To demonstrate, let's select a face. Left click. So now I'd like to introduce the manipulator. Think of this as a digital clay. The T-spline body is the clay and the manipulator is our hands. Currently, we are now in the multi-transform mode. Also, we have the option to go for translation mode, rotation mode, and scale mode. All of these three are available in the multi-transform mode. In addition, we have the option to select a coordinate space. So currently, we are now in world space. We can also go to view space and local. Also, we have options for filtering selections. Notice that we are given shortcut keys, so take note of that, as they are all very useful. For vertex, take note that if I make a window selection, notice that I am only selecting vertices. Selecting edge and making a window selection, notice that all edges were only selected. Selecting face and the ability to select all. And finally, selecting only a body. Also, we can snap to objects, soft modification. Under selection options, we have options available to grow, shrink, loop, grow, shrink, ring, grow, shrink, select next, invert selection, range selection, and finally our three display modes. In addition, if I double left click a face, notice that I have selected all of the T-spline body's faces. Left click on the blank canvas to deselect. Now if I select an edge and double left click, notice that I have selected the whole ring. Left click anywhere on the blank canvas to deselect. Let's check out translation mode. Selecting this face, going to translation, dragging this arrow. I'm going to press Ctrl Z. This one, Ctrl Z again. Or we can move them in a planar fashion. Again, Control Z. Moving forward, let's select rotation. I can grab the blue dots to rotate and manipulate the angle. Control Z again. Finally, let's check out scale. I'm going to double click this horizontal edge. Notice that I am scaling in the horizontal plane. I'm going to press Control Z again. Please do familiarize yourselves with the manipulator. Left click to deselect. Grabbing the Alt key and going into translation mode. Selecting this face. I'm going to press Alt and left click, holding them both as I drag this arrow. So take note that we have extruded or added AU material. Again, Alt and left click, holding them both. Friends, that is our manipulator in the edit form. In the next lesson, we'll create a form based on a reference image. You have noticed that my environment is different. You may change yours by going to Display Settings, Environment, and selecting Gray Room. Moving forward, let's go to Insert, Attach Canvas. For the face, let's select our XY plane. Left click to select. For the image, browse and locate 29knife.png. I'm going to click Open. I'm going to select Display Through. For now, let's leave canvas opacity to 100. We don't want the canvas to be selectable, so let's leave this unchecked. I'm going to go to Front View. Let's select this arc. Left click and drag diagonally. Going to the dialog box and key in a value of 5 and press Enter. Let's calibrate this image by indicating its size. Expanding the canvas folder. Going to 29 knife and right click and calibrate. Now we are prompted to select the first point on the canvas plane. Let's zoom in. Let's define the length of the handle as 110 millimeters. Let's place our first point here. Left click. The other point to be here. And key in a value of 110. Pressing Enter. So now this handle in Fusion has the length of 110 millimeters. Let's now proceed to Sculpt Workspace, going to Create Form. And let's create a box. For our plane, I'm going to select our XY plane. Left click. For the rectangle type, I'm going to select 2 point. I'm going to hover my mouse above the origin. Left click. I'm going to pan. And placing our next point here. Left click. Hit OK. Our goal is to turn this primitive box into the form similar to this handle. We can achieve that by going to Edit Form. Also, we'll be learning the application of the different display modes. Again, Alt 1 is box mode. Alt 2 is control frame mode. And Alt 3 is smooth mode. Going back to Alt 2, which is control frame. Basically, this is the view of box and smooth mode combined. I'm gonna go back to front view. I'm gonna press Alt 1. I'm gonna make a window selection to select this middle edge. Going to modify and selecting insert edge. I'm gonna target our edge to be here, 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 and here. Grabbing our slider to move it to position. Hit OK. I can go back to modify or right click in the canvas and repeat insert edge. Selecting this edge and double click to select the whole ring and moving our edge into position. Hitting OK. I'm going to hold and drag my right click upwards to repeat insert edge. Double click this edge, dragging our slider for the edge to be in position. Hit OK. Create a window selection to select the edge. Right click, edit form, grabbing the blue arrow to move the edge into position. In the next lesson, we'll continue sculpting the lower portion of the knife. Right area. I'm gonna make a window selection to select this top edge. Let's go to select and go to selection and filters just to make sure that everything is active. We're gonna make this edge aligned with the knife's handle. Again, creating a window selection. I'm gonna rotate the model just to make sure that all faces are also selected. A quick tip, make it a habit to rotate your model just to make sure that you have selected the right entities. Going back to front view, grabbing the blue dot to create an angle. Grabbing our planer handle and aligning it to the knife's edge. Left click outside to deselect. Again, let's create a window selection to select the lower portion. Turning our rotation handle. Selecting the planer handle. Next, let's grab this edge and transform this upward. Panning. Pressing Alt 3 to go back to smooth mode. Going to box mode. Smooth mode. Let's align this portion. Going to control frame mode. Selecting this edge. Grabbing our planer handle. Window select the lower portion. And again, grabbing the planer handle to align. Zooming in. Selecting this edge and nudging it a bit. Selecting the upper edge. Nudging. Inspecting our model. Inspecting the upper portion. Window select the upper portion. Moving it downward. Inspecting. Window select and nudge it again downward. Inspecting. Now let's target this area. Going to box mode. Switching to control frame mode. Pulling this upward. Going back to smooth mode. The middle section is now aligned. Going to box mode. For this portion, I'm thinking of inserting a new edge. Windows, select this edge, go to modify and insert edge. Moving our edge to this position, hit OK. Going to control frame mode, Windows select, right click, edit form, pull this upward, inspecting, Windows select this edge and pull it downward. Selecting this portion and rotating it at an angle. Reselect that portion and pull it upward. Select this edge and nudge it downward. Windows, select this edge and insert another edge. Position this edge here. Hit OK. Selecting this edge, edit form and nudge it upward. Select this edge and move it to the right. Selecting this edge and moving it to the right and nudging it downward. I'm gonna pan. Selecting this edge, moving it to the left and up. Windows select and insert another edge. Moving it to the left. Hit OK. Selecting the bottom edge. Edit form, zooming in and nudging it downward. Going back to smooth mode. Selecting this face and edges, going to control frame, nudging upward. Zooming out. Pan. In the next lesson, we'll continue sculpting the right portion of our knife. I'm going to rotate and cycle through our different display modes. Going back to front view, I'm going to rotate and select this edge, control left click this edge. In addition, notice that this half is equal to this half. Left click outside to deselect our current selection. Let's apply symmetry. For our first face, let's select this face. And the other one is this face. Now we have this green indicator that this is our symmetrical plane. Going to front view, Windows select this edge and vertex and insert edge. Drop our edge somewhere here and hit OK. Windows select, right click, edit form. Rotate our edge at an angle. Windows select and rotate this as well and nudge it to the right. Zooming in. Windows select and nudge this down. Windows select and nudge this upward. Moving this edge to the left. Nudging this down. Moving this as well. Windows, select this edge. Move this down a bit. Windows, select this edge and rotate this. And move this down. Select this edge and move this up. I'm gonna double click this edge and rotate it just to check if it's all selected. Going to front view. Going to modify, insert edge. Drag our slider and position our new edge on the left. Hit OK. Inspecting. Double click this edge, rotate. Go back to front view, right click edit form, and move this to the right. Select this edge and move it up. Select this edge and rotate. And this edge, rotate again. Move this up. Select this edge again, move this up. Up again. Going back to this edge, up and nudge it. Nudging this to the left. Panning. So now let's focus on this area. Selecting our top edge and nudging this down. Let's insert a point. Going to modify, insert point. I'm going to rotate. Left click this vertex and go back to front view. Select this one, rotate, hit OK. Let's add an additional edge. Going to modify, insert point, selecting this point, going to top view and drop our point here, hit OK. Going to rotate to inspect. Window selection, right click edit form, select our vertical scale and drag this to the left, or better yet, key in a value of 0. Going to front view, window selection, right click edit form and nudge this to the right. Let's add another edge. Gonna rotate. Select this edge. Control left click, control left click. Going to modify, insert edge. Going to front view and dropping our edge here. I'm gonna hit OK. Selecting this edge, right click, edit form, nudge up. So now let's focus on this area. Gonna rotate and we're going to add a new edge. So I'm going to modify, insert point, left click this point and left click the other side and hit OK. Going to front view. Gonna rotate, select these two edges and go to modify, insert edge, moving the edge up. Going to front view, drop this in the middle and hit OK. Window, select this edge, right click, edit form, and move this to the right. Selecting the top left edge and nudging this, zooming in, reselecting and refining our form. Checking, and we are nearing completion. I'm going to select this edge, nudge to the left, select this one, and nudge this again. I'm going to rotate, and pressing Alt 3 to smooth display mode. Going to front view, and congratulations, we have now created a form based on a reference image. Now I can hit finish form, rotate and hide our canvas. In the next lesson, we'll discover assembly starting with a rigid joint. One of the many powerful features of Fusion 360 is its ability to create assemblies. If you have used other CAD programs out there in the market, you may be familiar with the word assembly constraints, wherein the approach is you add more and more constraints to remove degrees of freedom. In Fusion 360, the keyword for assembly is joints, where you explicitly open degrees of freedom, and these open degrees of freedom mimic mechanical behaviors. This is a very logical approach in doing assemblies in Fusion 360. Open up your exercise file. We have here a set of components above to be placed on our base component. Take note that if we have started creating joints, a folder here with the same name will be visible. Now, unconstrained components can be moved by left-clicking and hold. So again, left-click and hold. I can move components that are not constrained. A good practice in doing assemblies is to first fully constrain the parent component. In this instance, our parent component is this base. Now, I'm going to Browser, Base, right-click and select Ground. Notice that we cannot move the base component anymore, as it is fully grounded. Let's now apply a joint. I'm going to go to Assemble. Take note, our shortcut key for joint is letter J. Left-click to select. If you have this dialog, select Capture Position. Take note, when joining components, the last component to be selected, the first one will follow. If this is my first component, I'm going to select the center, left click, and this is the second component. This first component will move towards the second component. I'm going to left click the center of this component. Notice the first component that we have selected moved toward the last component. I'm going to press Ctrl Z to undo. Hit cancel. Again, going back to joint, we're going to press letter J. Capture position. Because our base component is grounded, notice that it is grayed out. Now we are prompted to select our first component. Our intent is to position our diamond component into the diamond slot of our base. Going back to our diamond component, zooming in, notice that if we hover our mouse on our component, we are given snap points. Slowly, let's hover our mouse over this face. Now I'm going to press Control. Notice that if I go back to this top face, take note that we are locked in the first face that we have selected. And that can only happen if we press Control. I'm going to release the Control key. Let's hover our mouse again on this top face. Notice that this face is now unselectable. Now, our intent is to select the bottom face. I'm going to press and hold my left mouse button. And now we are given options on what entities to select. Selecting the bottom face, left click. And now I'm going to hit Control, holding it, and select the center snap point. Left click to select, zooming out. Moving to our base component and selecting the face and center snap point. So notice the rigid type joint snapped our diamond component into the base perfectly. We can grab this blue arrow to give it an offset. I'm going to revert back to 0. In addition, we have the option to flip and to animate and hit stop. I'm going to press OK and attempt to move our component. Notice that it is now fully locked in. Now, if you are using other CAD programs, you may have noticed that you have to apply probably more than one constraint in order to lock this into position. Zooming out, let's apply another joint to our block and base components, positioning our block into this slot. Pressing letter J for joint. I'm going to hover my mouse on this face. Press and hold my left mouse button. Selecting our bottom face. I'm going to press Control to lock in and select our center snap point. Left click to select. So now for component 2, I'm going to hover my mouse on this face and select the center snap point. Again, that is our rigid joint. I'm going to press OK and try to move this one. The next lesson we'll discover the slider joint. Our intent is for this block to slide on this surface. We're going to assemble. Left click to select joint. For component 1, let's zoom in. I'm going to press and hold my left mouse button. Selecting the bottom face. I'm going to press Control to lock in and select our center snap point. So now, I'm going to select the center of this surface. Left click. Witness the block moving to our base. Let's change the motion type to slider. Notice a while ago that the movement of our block was upward. That is not our intent. Our goal is for this block to slide in this direction. Going to slide, and I'm going to select Y-axis. Now it is moving in the right direction based on our intent. I can now press OK. If we select this component and move it, notice it is now sliding on our desired direction. That is our slide joint. Moving forward, I'm going to hit letter J again. Capture position. Let's change our motion type to pin slot. For our first component, I'm going to zoom in. Hold my left mouse button. Select the bottom face. Press Ctrl and select the center snap point. I'm going to rotate. And now I'm going to select the center snap point of this slot surface. Left click. Notice our pin moved in the wrong direction. And as you can see, our slot is at an angle. I'm going to go to Slide, left click and select Custom. And for our direction, I'm going to select this edge. Left click to select. Pressing the play button to animate. And now it is moving on our desired direction. I'm going to press stop and hit OK. Let's move our pin. Left click and drag. And that concludes our pin slot joint. Finally, let's discover planar joints. I'm going to press letter J. Again, we have this dialog to continue or to capture position. Notice a while ago that we have moved this pin. So if I hit continue, it will revert back to its original position. I'm going to hit continue. For our motion type, I'm going to select planar, zooming out. In this scenario, our design intent is to have the bottom surface of our pentagonal component be planar with the top surface of our base. I'm going to zoom in, holding down my left mouse button to select the bottom surface. I'm going to press Ctrl and select our center snap point. Zooming out. Let's select the center snap point of this face. Left click. In addition, whenever we enter the joint command, we are also given this dialog box in which we can select our preferred joint types. So going back to planar, we have captured our design intent. So we can now leave normal and slide to Z and X axis. And finally hit OK. Going to isometric view. Left click to move our pentagonal component. Notice that it is now locked to this planar surface. Let's go to front view. Once more, let's move this component. Ladies and gentlemen, that is planar joint. The next lesson will discover revolute cylindrical, and ball joints. I'm going to press letter J for joint. Our intent is the center point of our revolute component revolve on the vertical axis of this hole. Going to our revolute component, zooming in, I'm going to press Ctrl and select our center snap point. And now, I'm going to press Ctrl to lock on this face and left click to select the center snap point. Our intent is to make a revolute joint, and currently we are in ball type. I can modify it here or here. Left click and select revolute. So now it captured our design intent. I'm going to press animate, click stop, and press OK. Double click my middle mouse to zoom extents. Moving forward, I'm going to select joint. And for motion type, I'm going to select cylindrical. So now our design intent is for this rod to be inserted into this cylindrical hole. For our first component, I'm going to hover my mouse on the middle section. Left click, zooming in. I'm going to select the midpoint and center of this cylinder. Left click. So now it captured our design intent. I'm going to click animate again. That is our cylindrical joint. I'm going to hit OK. Finally, let's proceed to ball joint. Hitting letter J and going to motion type. Selecting ball. Zooming out and moving to our ball component. I'm going to rotate and zoom in. Rotating in order to have a good view of our snap point. Left click the center of our ball component. Moving to our base component. Notice if I hover my mouse on this face, I can now press Ctrl and select the center. We have now successfully created a bolt joint. I'm going to press animate again. Press stop and hit OK. Going to isometric view. Going to our browser, notice in our joints folder we have revolute joint, cylindrical joint, and bolt joint. Here we can right click to drive joints, edit our joint again, key in joint limits, lock, animate our joint, and animate the whole model. In the next lesson, we will discover as-built joints. Let's open up 35 as-built joint.stp by going to New Design from File. I'm going to go to ASCII Guide X, right click and capture design history. Take note that this is an STP file imported to Fusion 360. As you can see in our browser, this imported file has no joints yet. Whenever you import a non-native Fusion assembly file, the best way to apply joints is by using as-built joint. And the shortcut key for that is Shift letter J. Going back to our assembly As you can see, all of these components have their own degrees of freedom. I'm going to hit Ctrl Z. I'm going to go to component long X, right click and ground. Notice that it can't be moved anymore. Next step is going to assemble as-built joint. For the motion type, we're going to select slider, and the components would be U-bar and long X. So now we're prompted to select a reference. Take note that long X is sliding along this axis. So I'm going to click this edge and hit OK. Again, going back to assemble as-built joint. For the motion type, we're going to select revolute. For the components, it'll be U-bar and pin roller. Left click, zooming in. I'm going to press my left mouse button and hold. And select the cylindrical face of our pin roller. Left click. Select the center. Left click. And hit OK. Zooming out. Ctrl Z. Going back to assemble as-built joint. The components would be pin stopper and pin roller. Zooming in. Again, holding my left mouse button. Selecting this face. I'm going to select this face. And select this center point. And hit OK. Double click my middle mouse to zoom extents. I'm going to move our timeline marker to disable and suppress the previous joint. A quick note, if this assembly was imported and the true position of our, let's say our pin stopper was here, now your best bet would not be as-built joint, but it should be joint. So as-built joint is a powerful tool to use when the assembly is pre-assembled. I mean pre-assembled in its true design intent. To demonstrate, I'm going to go back to assemble as-built joint. Capture position. Now assuming that the placement of the native STP file in which the pin stopper is originally here, and I'm going to apply as-built joint. So selecting components, pin stopper and pin roller. The motion type should be revolute. Zooming in. And I'm gonna click our center point. Zooming out, so notice as we animate, the component is revolving on the wrong axis. I'm gonna hit stop and cancel. Undo. And revert back to our previous joint. If you have an imported assembly file which is already in position, your best bet would be as-built joint. In the next lesson, we'll be discovering joint origin and rigid group. Moving forward to joint origin, you design from file and grab 33 joint origin.f3d. Joint origins are like points. They are helper tools. In this scenario, I have pin blade, and we'd like to position this on this surface. So grabbing pin blade and moving it. To demonstrate, I'm going to grab our joint tool, capture position. The first component is this one. I'm going to select the back side, left click, holding it, select this face, select the center, and now we're looking for a point to position this into this surface. So our intent is to position our pin blade here. As you can see, we don't have any reference points. So this is where joint origin comes into place. I'm going to hit cancel. Going to assemble, joint origin, capture position. Moving into the surface of our plug body, left click, going to front view, zooming in, I'm going to select this point and grab our arrow. I'm going to key in a value of -15 and press OK. So now I can apply a rigid joint. I'm going to press letter J. The motion type is rigid. And the first component is our pin blade. Holding my left click, selecting face, selecting the center. And for component 2, let's select our newly created joint origin. Left click and hit OK. So now we have our pin blade properly positioned with the aid of joint origin. Again, going back to assemble, joint origin, selecting this surface, selecting this point, dragging our arrow, keying a value of -15 and hit OK. I'm going to select our pin blade, press Ctrl C and Ctrl V. Moving this, pressing OK, going to assemble, selecting joint, holding my left mouse, selecting this point, and selecting our joint origin. And finally, pressing OK. So now our flag assembly is now complete. Moving forward, I'm going to hide our components. Turning on base block and capsule. Turning off pin blade 2. In this scenario, our intent is to position our capsule somewhere here with the aid of our joint origin. So going to assemble, joint origin. For type, I'm going to select between two faces, selecting this first plane and the second one. So notice it gave me a mid plane. So if I hover my mouse over this point, notice that there's a broken line projecting a point on our mid plane. So moving to the center, I'm going to left click this one. So now we have our joint origin here. Going to front view. I'm going to grab this upward. Let's key in a value of 30. I'm going to press OK. And now, going to assemble, joint, applying rigid joint. For our first component, I'm going to select this center, left click, and our joint origin. Gonna hit OK. To conclude, in the absence of assembly references, joint origins is your best bet in this type of situations. To demonstrate rigid group, let's open up and reuse our previous as-built joint assembly STP file. Going to ASCII guide, right click and capture design history. I'm going to ground our long X component. Going here, right click and ground. Rigid group is somewhat similar to fixed constraint. Now going to assemble, rigid group for components. Let's select our pin stopper, left click, our pin roller, and finally our U-bar. I'm going to hit OK. So now, if I drag our pin stopper and select this one, so notice they are all now grouped into one, being as a rigid group. So I'm going to press Ctrl Z. And finally, we can now apply an as-built joint. So for motion type slider, components would be our U-bar and long X. For our reference, I'm going to select this face and this point. Left click. And finally hit OK. So notice the direction suddenly changed. I can now double click my joint and change this one into an X axis. I'm going to press OK. Going back to home view and I'm going to drag this one to check. So ladies and gentlemen, that is our rigid group. In the next lesson, we'll be discovering Autodesk A360. An overview, Autodesk A360 is a cloud-based collaboration platform that provides design and engineering teams a centralized platform to work together on projects more efficiently. Going back in Fusion, selecting Data Panel, this is where your files get stored and shared for collaboration. Moving forward and going to your favorite web browser and keying in Autodesk360.com, because we are logged in Fusion 360, it automatically logged us also in Autodesk A360. Take note of these 4 folders. If we go back to Fusion 360, these are also the 4 folders that we have seen a while ago in our web browser. Now if I hover my mouse on my name, notice open GeoMark in browser, left click, and now we will be redirected again to our A360 account in our web browser. There are 2 ways to create a project. One is in our web browser in A360, create project, and the other one is in Fusion 360, create new project. I have already gone ahead and created a new project of mine, which is part modeling exercise. So take note, if you have created a project here in Fusion 360, it will automatically reflect in your web browser similar to this one. So now my part modeling exercise is also in my A360 web browser. Let's open up this folder. double left click. Notice in this folder I have team members Charlene, Ace, and Ryan. I can also add additional people in our project by going to invite and key in their email addresses. I'm gonna hit cancel. Also, notice that we have different files here. We have a Fusion file, a JPEG, PNG, and you can also go to upload and select a file to be included in your project. We can also be more organized by creating new folder inside your project. Moving here to activity, we can see here the recorded activities of our team members and the date in which they have uploaded and saved a new version. Going back to details, you can go to view all and again invite an additional team member. And notice that I am the creator of this project and being indicated as an admin. I'm going to scroll down and hit close. Let's go to Charlene's file. So here we can also share. I can hit export and we have different file types in which we can export Fusion. You can also edit, copy, rename, and delete this part. And if I double left click, we'll be redirected to this new page. Going to design references, we can determine the uses of our model, where it was used in, and the drawings to where it is associated into. But for now, obviously, this item does not reference any other designs. Going up again, moving to our right, we can also add comments. We can also go to shared link to share our file. Here we can copy this link to share it to someone. Also, we have the option to share via email and add a personal message. And finally, we can embed our 3D model into a web page. Scrolling down, I'm going to hit close. Moving to our file name, which is chat. On the right is our version numbers. Left click to view. As you can see, we are now in the third version of this file. Here we have information on the time and date it was updated and saved. Also, we have the option to view the file. And we can promote a version to be the latest. And reminding you that all of these functions are also available in Fusion 360. In the next lesson, we'll discover live review and managing new file versions in Fusion 360. I'm going to open up our Show Data panel. Currently, I am in the part modeling exercise project. Now going to the part which is chat, I'm going to do a right click and share public link. If you can recall, we also have this feature in A360. I'm going to close this dialog box. At the bottom right of our thumbnail is this icon letter I. Left click to select. Here we can see information on when this file was updated. Moving down, we can click here to see other versions. Left click. Loading. So now we can see a version 2 and version 1. We have the option to promote version 2 to be the latest version. And again, we can open details back into A360. Let's say we have a scenario wherein we are instructed to revise this part. Going back to chat, right click and open. Now our design manager's instruction is to change the angle of this surface from 105 to 110 degrees. Let's hide our data panel. Let's select the top surface. Left click. This is to determine where this feature is located in our timeline. And obviously this is the sketch. I'm gonna right click, edit sketch, and change the value of this dimension into 110 degrees. Pressing enter and going to stop sketch. And now I can hit save. Let's change the version description to 110 and hit OK. Now it's creating a new version. New version created. Going back to our data panel. Currently loading. Now we have an information that we now have a new version updated by me. Left click. And now obviously version 3 is no longer the latest version. Going back to A360, left click. Going to versions. Here we can see that I have uploaded a new version. And if you remember a while ago, in the version description, I placed 110. So here it is. Moving up is our help menu. Next is our download tool. Here we can export this file into different file types. Again, we have our share button and live review. Let's proceed to live review. I'm going to hit start. Rendering the chat file. Moving to our right, notice the plus sign. Here we can copy this link and share to others in order for our stakeholders to participate in live review. Live review is one of the powerful tools of A360. Here we can conduct a real-time design review. All actions that we are doing in this model will also be reflected to anyone who was invited and participating in our live review. So if I rotate this model, they'll be seeing this model rotate as well. And whatever actions that we perform here will also be seen by our participants. Moving forward, again, we have a commenting tool. And here you can see that I am the host of this live design review. This is one of the very notable tools that A360 offers. And obviously, participants without Fusion 360 can participate in this live review. Let's now end this live review session. and say yes. Session has been ended. Going back to our previous tab. In addition, we can view our file. Notice this is very similar to live review. And finally, we have an option to open this file in Fusion 360. Yes, folks, this is the power of Fusion and A360 combined. In the next lesson, we'll be creating a part drawing. Hi everyone, in this lesson, we'll be discovering part drawing. Let's open up base-cylinder.f3d. Next, my preference is third angle projection. Selecting preferences. I'm going to go to drawing. For standard, I'm going to select ISO. I'm going to tick override or restore format defaults below. For projection angle, I'm going to change it to third angle. For the sheet size, I'm going to select A4 297 by 210. Apply and hit OK. Going to File, New Drawing, from Design. Notice it updated our default sheet size. I'm going to hit OK. And now we are in the drawing workspace. I'm going to go up, going to Base View, left click. So now we are prompted to specify location of base view. I'm going to go to our View Properties panel. To orientation, I'm going to select top. For the scale, if I select 1:4, let me select 1:2. So the pertinent scale for this one is 1:4. And I'm going to place our base view here, left click. For the edge visibility, I'm going to make it full length. And for the style, I'm going to make it sure it's visible and hidden edges. I'm going to hit OK. I'm going to add the outer diameter of this circle. Going up to annotation, selecting this one, going down, and selecting diameter dimension. Left click. So now we are prompted to select an arc or circle. I'm going to select this circle, left click. I'm going to zoom in and drop our dimension here. Left click again. I'm going to hit escape to disable the command. Let's add the outer diameter of this circle as well. If you remember, our previous command was a diameter dimension. So what I can do is right click, go up and repeat diameter dimension. Left click, zooming in and selecting this outer circle. Left click to select, zooming out. And let's place our dimension here. Left click again. I'm going to hit escape. There are 3 instances of this diameter. So I'm going to go over our dimension, double left click, move our cursor to the left here, left click. I'm going to key in number 3 and X, hit space, because the instances of our circles are 3. So 3 times the diameter 35. I'm going to left click outside. Moving forward, let's apply center marks on this 3 and 4th holes. So this is our center mark. We can also access it here under annotation and selecting center mark. So now we are prompted to select a hole or rounded edge. This one is a hole, so I'll be selecting this hole. Left click. This one as well. This one, and finally this one. Right click and hit OK. Also, take note that our dimension tool can also perform the tasks of creating linear, aligned, angular, radius, and diameter dimensions. Left click. In addition, if we double left click a specific dimension, we are given this dimension properties. We can assign the precision. We can have alternate units. We can specify tolerance, if it's symmetrical, if it has deviation, and limit. I'm going to revert back to none. Also, we can do a representation if it's a reference dimension, if it's not to scale, if it's theoretically exact. And finally, the option for inspection, which can be round, angular, and no frame. I'm going to hit close. I'm going to double click my middle mouse to fit and head up towards to projected view. Left click to select. So now we are prompted to select a parent view. So obviously this is our base parent view. Left click to select. Specify location of projected view. I'm going to drop my first projected view here. And the other one here. And finally, I'm going to right click and hit OK. As you can see, my projected views have visible and hidden edges. I can change that by double left clicking on a specific view, going to style, and change it to visible edges. Hit close. Same as here. Double click and selecting visible edges. Hit close. Going up to base view. For orientation, I'm going to select northeast isometric. And for the scale, I'm going to select 1:4. And place it here. Left click. And finally, hit OK. So again, I'm going to change the visibility of my edges. Double click. And for style, I'm going to change it to shaded with visible edges. And hit close. In the next lesson, we'll be creating a section view. Moving up, going to section view. We are prompted to select a parent view. I'm going to select this view. Left click to select. I'm going to zoom in. I'm going to hover my mouse on the center point, or better yet, midpoint of our circle, and slowly moving to the left. Specify start point. Left click here, move to the right, and drop our second point here. Right click and hit continue. I'm going to double click my middle mouse to zoom extents. So notice specify location of section view, press shift to cycle between, maintaining alignment and break alignment. So I'm gonna press Shift and move my mouse to the right and drop our section view here. Left click. Gonna maintain this one to visible edges. Let's retain the scale to 1:4 and the tangent to be full length and hit OK. So now we have a section view. Yes, the hatch pattern can be customized by hovering our mouse on the hatch, double click. So now we have the hatch properties dialog. We have different types of pattern here. You can adjust the scale factor and the angle. Let's say 90. And hit close. Moving forward, let's apply center lines on these holes. Going up to annotation, selecting center line. And now prompted to select first edge. Let's select this edge. Left click and this edge. So notice it produced a center line. Next, let's add another one for these holes. Left click and left click. This one as well. And select this one. Right click and hit OK. I'm going to move up and grab our dimension tool. Left click to select. I'm going to specify the diameter of this hole. I'm going to select this endpoint and this endpoint. And left click. The dimension tool is still active. Let's apply the pitch diameter of our 3 circles, or better yet, 3 holes. I'm going to select the endpoint of our center line, left click, and the other one, left click, and drop our dimension here. Next, let's dimension the diameter of our 3 holes. So I'm going to zoom in, left click this point and this one, move up, and drop my dimension here. Zooming out. I'm going to right click and hit OK. Next, I'm going to add diameter symbols for these 3 dimensions. Before that, I'm going to go down to zoom window, create a window here, left click, zoom out a bit, selecting this dimension, double click. I'm going to place my cursor on the left, and on my keyboard, I'm going to hold Alt and 0216. Left click outside to close. Also for 25, double click, move my cursor to the left, Alt 0216. Again, moving my cursor to the left. Notice that 25 is occurring 3 times. So let's place 3 and X, space, and hit close. Same with 135, double click, place my cursor here, hold and press 0216, Alt, and notice that this is the pitch diameter of our 3 holes. So I'm going to drop my cursor to the right, press space bar, open parentheses. I'm going to input pitch close parentheses, and left click outside to close. Moving to fit. Finally, let's specify the dimensions of our 6 chamfers. So again, going up and grabbing our dimension tool, I'm going to zoom in, selecting this endpoint and this one, moving up, and drop it here. I'm going to hit escape, select our dimension, grab this handle, and move our dimension to the left. Left click. I'm going to specify the angle of our chamfer. So I'm going to go to our dimension, pressing escape, going to our dimension, double left click. I'm going to drop my cursor to the right, hit space bar, press X, and key in 45. And finally, I'm going to press and hold Alt and 0176 for the angle. And finally, hit close. I'm going to go back to fit. The next lesson, we're going to add a detail view and we're going to populate the title block. Beforehand, let's define the height of our base cylinder. Going up and grabbing our dimension, let's define the height of this base. Selecting the endpoint, selecting this one, zooming in, and placing our dimension here. Next, I'm going to go up to annotation, select baseline dimension. For our base dimension, I'm going to select 35. Specify second extension line origin, which would be the top endpoint. Left click to select, right click, and hit OK. Again, that is our baseline dimension. Allow me to demonstrate chain dimension. For our base dimension, I'm going to select 35. We are asked to specify second extension line origin. I'll be selecting this endpoint and this endpoint. Right click and hit OK. And finally, I'm going to double click to select our 115 dimension. Head to dimension properties, expand representation, and grab our reference dimension. And hit close. I'm going to double click my middle mouse to zoom extents. And now going up and selecting detail view. Now we are prompted to select parent view. Selecting this one. I'm going to zoom in. Specify center point. I'm going to make my first selection here. Move my cursor to create our circle. And drop it here. I'm going to double click my middle mouse to zoom extents. Pan and zoom over this area. And place our detail view here. For style, I'm going to select visible edges. Tangent to be full length and hit OK. Again, zoom extents. Moving back to our parent view, I'm going to select this one, grab our handle, and move our tag zooming in and place it here. Zooming extents. So if I select our detailing circle, I can grab this handle and resize our detail view. So if I release it, notice that it also updated our detail view. So going back to our detail circle, I'm gonna resize it and left click, zooming extents, going up and grabbing our dimension tool, zooming in, selecting this endpoint and this endpoint, and place our dimension here. The tool is still active, so selecting this one and this endpoint, left click, zoom extents, and going to indicate the radius of our fillet. Moving over here, left click, zooming out, and place it here. Right click and hit OK. Zoom extents. Fusion 360 has tools for GD&T. To demonstrate, I'm going to go to our parent view, go up, select feature control frame, left click, let's select this inner circle, which is our hole, left click, specify our next point here, right click and hit continue. So here we have the different geometric symbols. I'm going to select position and input a tolerance of 0.5 millimeters. So here you can make it all round. You can add top node, bottom node, and you have the second frame to activate. So feel free to discover and grab your own set of GD&T tools. I'm going to hit OK. In addition, Fusion 360 has a datum identifier. Moving up, selecting for our object, selecting this line for start point, left click here, moving to the right, left click, I'm going to right click and hit continue. I'm going to leave identifier as A, leave datum node and thread node blank, hit OK. I'm going to reposition my datum identifier, left click, grab the grip, and place it here. Press escape. I'm going to zoom extents, zooming out. I'm going to reposition my base view, going to modify, move, selecting this object, right click, continue, specify my base point at the center, left click, zooming in, and moving my base view up. So notice that the projected view also followed. Next, I'm going to grab our detail tag, select this one, grabbing the grip, zooming in and pan, and drop our tag here. Zoom extents. I'm going to move our 3D view, selecting this one, grabbing the grip, and moving it here. I'm going to press escape. I'm going to add a text. Going up to text, specify first corner, left click here, and drag to create a window. Left click. I'm going to type all caps 3D view and left click outside. Zooming in, selecting my text, grabbing our grip, and positioning this one to be at the middle. Left click, hit escape, zoom extents. I'm going to reposition my detail view. Left click, selecting the grip and moving this up. Zooming in, grabbing our text and nudging this down. Left click, zoom extents. Currently, as of this date and time of this recording, the title block for Fusion has no customization. Moving forward, let's now select our title block, double click, and now we are given title block properties in which we can specify the pertinent details. I'm going to input geomark into created by. For title, I'm going to input base space cylinder approved by plural site. For revision 01, and the rest I'm going to leave it blank. And finally hit OK. In the next lesson, we'll be creating an assembly drawing. Going to File, New Drawing, selecting from Animation. I'm going to accept the default for version description, hitting OK. I'm going to minimize our animation timeline. Moving up to our toolbar, selecting Transform Components. Selecting Shaft Handle. Control select Shaft Link. Selecting the arrow and dragging our components upward. Selecting Fit. Left click anywhere on the white space to deselect. Once again, reselecting Shaft Handle. Moving our component up. Selecting Fit. And hit OK. Left click anywhere on our white space to deselect. And now going back to File, New Drawing from Animation, accept the defaults and hit OK. We have only one storyboard, retaining the standard for ISO and units in millimeter. The sheet size, I'm going to change it to A3 and hit OK. Now we are prompted to specify location of base view. But before that, I'm going to head up to my profile, selecting the drop down, going to Preferences, moving to Drawing, reminding you that previously in our drawing, we override or restore format defaults below, and we change the projection angle to third angle. I'm going to hit Cancel. Back in base view, and now we are prompted to specify location of our base view. Notice that the assembly is small. I can go to View Properties, going to Scale, selecting 1:4, and drop my view in this position. Left click. Going back to View Properties, Edge Visibility, I'm going to select Tangent Edges and select Full Length, and finally hit OK. Moving up to our toolbar, let's add a Bill of Materials parts list. Selecting this one. And now we have a BOM table. Specify location of parts list. I'm going to head up to our upper right and snap to this endpoint and left click. Let's add a bomb balloon on our components. Moving up, I can select balloon here or go to our drop down and select balloon again. Left click, select component edge. Going to select this one and drop it here. Next, select another component's edge, selecting this one. And finally, selecting this edge and position this here. Right click and hit OK. Notice the numbering assignment of our components as 1, the shaft handle, 3, the shaft link, and 2, the base cylinder. We can reorder this one, and I'd like it to be 1, 2, and 3. So going up to bomb, renumber balloons, select balloon to number as 1. So we'd like this to be 1, this one to be 2, and this one to be 3. The first balloon to be selected will be the first, and the second one, the second, the third, so on and so forth, will be the numbering assignment. So I'm going to hit OK. So notice it now updated into 1, 2, and 3. 1 being our base cylinder, 2 being our shaft link, and lastly 3 as our shaft handle. In addition, Fusion 360 has the ability to align number balloons. I can go up to bomb, align balloons, select balloons to align. I want this one here and this one to be aligned vertically. So I'm going to right click, hit continue. I'm going to drop my first start point on the center of our third balloon. Left click and move slowly down. So notice the broken line. And finally, left click. And now my balloons are vertically aligned together. Let's update our bomb parts list table. And we may be tempted to go over here and double click. Notice that nothing happened. I'm going to hit escape. The only way we can update our description is by going back to our assembly or component. I'm going to head back to our first tab, going to model, going to our browser and selecting base cylinder, right click, and proceed to properties. So here we have the description. To demonstrate, let's add a description. Let's say base component. Hit OK. Left click to deselect, going to shaft link, right click, going to properties. Let's add connecting link to our description. Hit OK. And finally, to shaft handle, right click, go to properties. I'm going to type rotating handle on our description and hit OK. Moving back to our drawing, notice on the material column, all of our materials are steel. Let's say I'd like my shaft handle to be aluminum. Going back to our assembly, in our browser, going to shaft handle, right click, going to physical material. So now we have our library for material. I'm going to go down to metal folder. Moving down, I'm going to select aluminum anodized blue. Left click this one and drag and drop. Going to close. Let's add another material to our base cylinder. Going to our browser and right click base cylinder. Physical material. Scrolling down. I'm going to select aluminum anodized red. Drag and drop. Hit close. Moving up to our application bar. I'm going to hit save and hit OK. Moving to our drawing. Notice the warning symbol. I'm going to select this one and hit get latest. So notice our parts list updated. Take note of our description and new materials. Just to add, moving to our exploded view, double click, going to style, and let's select shaded with visible edges to see the colors being applied. Left click, hit close, and now it updated to blue and red. Feel free to add a title here using text or populate the title block. And finally, at the bottom on our navigation bar and display settings, we have here annotation settings. Here we can change the annotation font, annotation height, the precision of dimensions, the angular precision, display annotation unit, display trailing zeros, and we can also change sheet settings, sheet size to various sizes and format. In the next lesson, we'll discover rendering in Fusion 360. F3D by going to File, New, Design from File. A quick tip, it's a good practice to assign materials to your model as early as possible. There are two ways to access Appearance. One is by going to Modify, selecting Appearance. Take note, the keyboard shortcut is letter A. The next one is going to Workspace, Render, and here is our Appearance tool. Selecting Appearance. Now we are in the Appearance dialog. I'm going to scroll down to our library. Going to Paint, Glossy. Scroll down and select Paint Enamel Glossy Yellow. I'm going to click and drag over to this body. So notice that the material was applied to this body. It is because the Apply to Bodies components is enabled. Now, if we'd like a specific face to be applied with a specific color, we can select Face. Let's select Paint Enamel Glossy Red. Selecting this face, click and drag. So now, Paint Red was applied to this face. Going up, if we'd like to delete this color on this face, I can go here in this design, right click, and unassign and delete. Moving forward, I'm going to minimize rendering gallery. And now, let's apply a material to this base. Going back to library, scrolling down. I'm going to head to Wood, Finished, and select Oak Semi-Gloss. Notice, by default, some of the materials in our library is not yet downloaded. So here we have the option to download a specific material. But for oak, it has already been downloaded. I can now select this one and drop it here. My intent is for the whole body to be applied to. So I'm gonna go back up, selecting apply to body's components, selecting oak semi-gloss, dragging, and remove appearances apply to faces. I'm gonna remove. I'd like to apply a logo on this face. So I can do that by going to decal. But first, I'm gonna hit close, going up to decal. For the image, select Autodesk logo.png. For the face, selecting this face. So notice, I'm gonna move this one, selecting the warning, more info. The object that you are creating is not visible. I can resolve that by going to browser, turning on the decal. Once more, selecting this face. And now we can see the logo being applied. So I can go now to front view, selecting this circle, moving it to rotate, grabbing our arrow, selecting this one, and dragging this to be at the center. So again, I'm gonna revolve, position this to be at the middle, rotating, dragging this arc to scale, going to front view, and just to make sure that I am aligned, I can go to display settings, camera, and select orthographic. So again, nudging this, going back to display settings, perspective, and finally hit OK. Going to home view. Moving forward, let's now head to scene settings, left click. Under environment, we have the option to adjust the brightness. We can position our environment. So for example, I'm going to select rotation. For background, you have the option to select environment or a solid color. And for color, we can edit this one to our intent. I'm going to hit cancel. Under ground, we can flatten the ground. I can inject reflections. Under camera, we have orthographic, perspective, and perspective with ortho faces. In addition, we can adjust the exposure. We can enable depth of field, which can only be used when ray tracing is enabled. I'm going to hit close. Disabling this one. Moving down, we have aspect ratio. So we can select 16:9. I'm going to revert back to viewport aspect ratio. Under the environment library, we have options here to change our environment. For example, I'd like to select Crossroads. So I'm going to download the environment. Downloading. Download finished. I can now select Crossroads. Drag and drop. In order for the environment to be visible, I can head down to Settings and enable environment. Again, let's check out some of the environment. Also, we have the option to attach a custom environment. So you can open HDRI file. I'm going to hit cancel. I'm going to revert back to Plaza, selecting this one and drop. And finally, hit close. In the next lesson, we'll render this model using ray tracing and create images using the A360 Cloud Renderer. Material that we applied on our base is oak semi-gloss. Now we have the capability to edit that material. I'm going to go back to Appearance, or better yet, press letter A. So in this design, I can go over oak semi-gloss, right-click, and edit. So I'm going to pan and move this into view. Again, going back, right-click, edit. So here, we can tweak the parameters for scale, rotation, roughness, reflectance, and go into advanced editing. I'm going to hit close. For basic editing, again, right-click, edit. We can tweak the scale. So notice it automatically updates the wood. We can tweak the rotation and the direction of the grain. Another one is roughness. So this parameters is fine with me. I'm going to click done and hit close. Going back to home view. In addition, we have the option to control the texture map. Selecting this one. For our selection, I'm going to select our base. For the projection type, I'm going to select planar. I'm going to select our x-axis. So notice that the grain direction of our oak semi-gloss moved with respect to our x-axis. I'm going to hit cancel. Moving forward, I'm going to rotate our model to have a good perspective. And now I'm going to head up to ray tracing. So for settings, under quality, we have quick, normal, and advanced. I'm going to retain normal. So basically, ray tracing depends on your hardware capability. The longer the elapsed time is, the better the render will be. In addition, if your hardware is not that powerful, under performance options, you have the option to limit the resolution. So ladies and gentlemen, Fusion 360's awesome feature, ray tracing. I'm going to hit close. And now we can capture this image and save it locally. Selecting render. I'm going to retain image resolution to current document window size and hit OK. So now we have the option to save it locally on our computer or save it in the cloud. Also, we can save it in different file types, namely PNG, JPEG, and TIFF. I'm going to save this one in JPEG and click Save. I'm going to open up our saved file, and this is it. How cool is that? I'm going to close this one now. Moving forward, let's now head to cloud rendering. Take note, this file hasn't been saved yet. So if I click cloud rendering, notice you need to save your design before using the service. I'm going to click OK. Go ahead and save yours now. Moving forward, I have gone ahead and saved our model into the cloud. So notice if I now expand our rendering gallery, notice that A360 have already gone ahead and created a render for us. So if I select this one, the cloud rendering dialog will open up. And now it's giving me a preview. I can render as turntable. I can download this now and save it locally. And finally, I can perform actions such as adjusting the exposure or deleting the image. We have the option to share the images to Fusion 360 Gallery or A360. Moving to the right, here we have the details on when it was rendered, image size, render quality, exposure, file size, and finally, we have the option to zoom to check out the quality. Now I'm going to hit close. Now going back to cloud rendering under our toolbar. So here we have the tab for presets and custom. For custom, we can adjust the render quality, the exposure, file format, the alpha transparency background, the image size, aspect ratio, width and height. Another cool feature is it gives us the estimated time on how long it will take to be rendered. So under cloud credits, this render will require 1, and we have a maximum of 16 per request. So because this is an educational version, I have unlimited cloud credits. Moving over to the presets tab, we have options here to render for web, mobile, print, video, and we can do a preview or make it final. So feel free to tinker and discover. I'm going to hit close. And finally, I'm going to select this front view from the cloud. I'm going to check this out and download this to my hard drive. And now this is the image coming from the cloud. I'm gonna close this one, minimize. Dear friends, congratulations for finishing Fusion 360 Essentials. I am confident from now on you are more equipped and able to imagine, design, and create a better world. See you on the next Plural Site title.